Okay, so in this video we're going to have a look at a revision for calculator paper 2. Now I really hope that you have come out of obviously a non-calculator paper feeling pretty confident. If not though, don't forget you still have 2 papers to make up for that, so it's nothing to worry about, nothing to panic about. Now, as again, like my previous video, I'm just going to very quickly discuss something that's important with the calculator paper. And again, it is shown on the front of the paper here. I'm going to highlight that exact same thing. You must show all your working. Now, this is probably more important than on the non-calculator paper, because on the non-calculator paper, obviously without your calculator, it's very hard to answer the questions without doing your working out on the page. But when it comes to the calculator paper, it's just by our nature, we tend to just rely on the working out being on the calculator and less than writing it on the page. Now, if you don't write down your working out, you are going to potentially lose out on an awful lot of marks. So I can't stress enough to you how important it is to make sure that you show your working out, and that's the big process sort of marks there that I want you to be making sure that you pick up on this paper. Now, what I've done in this video, obviously because there are a lot of topics that we went over in the previous video, so those of you coming from the previous video, I'm going to explain how this is going to work. Now, what I've done is I've started the video off by discussing all of the calculator topics that we didn't discuss on the previous one. Where it goes from there is it then moves on to a lot of the topics that we discussed on the previous video. Okay, and one further thing to mention is that when you are using this video, please bear in mind that when you are watching the video, look, all of the topics appear there at the bottom. It's taken me a little while to timestamp all of those, but they're all in there for you so that when you are going through a question, you know exactly what the question is called. If you go into the description, you'll see at the top there, we have part 2 for those of you that are doing the higher paper. Please do make sure you watch that if you are doing the higher paper. And then down below, look, you can see I've timestamped and linked as many of these topics as possible. So like the one on the screen there, standard form conversions, you can see that down there at 24 minutes and 30 where it starts, with the link to the full video on that, which you can then go ahead and open up and do some further revision and see some further questions. So please do make use of this, and again, like the previous one, please do like the video. I think we hit 426 likes, look, on the last one, which was fantastic. If we could hit 500 likes on a video, that'd be absolutely awesome, and then I'll probably make another video for a paper 3 as well, so that'd be fantastic. And if you haven't already, please do subscribe to the channel, because it does really help the channel out, and I really appreciate everybody for doing that and all the fantastic comments that everybody's leaving. So thank you so much, and let's go back to our paper. So obviously, if you didn't obviously get the opportunity to watch that video, you're going to benefit anyway, because you're going to see all of the topics. But if you did watch the previous video, you will see that there is a fair bit of overlap towards the end of the video, following on from some of the topics that we didn't mention on the previous one. But again, a lot of these topics didn't come up on paper 1, and a lot of these topics, even if they came up on paper 1, have the potential to come up again on paper 2 and 3. So it's a very good idea to make sure that you still revise these topics. So I've accumulated it all into one video for you, but just so you are aware, there is a point in the video whereby you will see some replicated questions and some replicated work from the previous video that you've already looked at. Okay, but with that being said, let's get started. Invest £150,000 in a savings account offering a compound interest rate of 2.4% per annum per year for 4 years. Work out the amount of interest that she earns. So I'm just going to underline that, the amount of interest, so a slightly different part of the question here. So compound interest does keep accumulating, so she earns more in the second year, more in the third year, in the fourth year, but we can take a very similar approach. We do 150,000 times it by 1.024 for 2.4%, and rather than finding out what that is and repeating myself, I'm going to do it to the power of 4, and that'll just keep timesing it by 1.024, adding on that 2.4% every year. And if we type that into a calculator, 150,000 times 1.024 to the power of 4, we get the answer £164,926.74 to the nearest penny. Now, just being careful on this question, because it does say how much interest does this person earn, does Emily earn? So we're going to want to subtract that original 150,000. So take away the 150,000. for this particular one, and that gives us £14,926.74 again to the nearest penny. So there's a bit of compound interest, just remembering this multiplier here and how that works with compound interest, not forgetting the 0 there, and putting, because if we were to put 1.24, that would increase it by 24%, so we don't want that one there. So a mobile phone costs £480 in the UK and the same phone costs $600 in America. The exchange rate is £1 to $1.29, where offers the cheapest price. So we have two options here. We could put them both into pounds or we could put them both into dollars. I'm going to decide to put them both into pounds. So as we can see, we've already got the cost in the UK is £480, but we're going to have to convert this $600. So looking at our exchange rate, the actual number itself, we get a bigger number in dollars. So we know that our answer here is going to have to get smaller. So we only have one decision to make, and that is either we times or we divide by this 1.29. Okay, so it's times or divide. Okay, but we know logically we're going to get a smaller number in pounds. So let's go for this. When we do convert back, we are going to divide. So it's going to be 600 divided by 1.29. And we'll do that on the calculator. 600 divided by 1.29 gives us, not a very nice number here, £465 and 12p to the nearest penny. Now it doesn't matter about all the decimals after that, because at the end of the day we're looking at which offers the cheapest value, and as you can see there, £465.12 is cheaper than 480. Obviously there is another way of doing this. We could convert them both into dollars. So instead of doing that, what I could do is times this number here by 1.29, and 480 times 1.29, if again we work that out on the calculator, gives us an answer of, in dollars, $619.20. And again, that's more than $600, so again we would state that it's cheaper in America. So it's important to know where lots of digits are. Pick quite a complicated one here, but you just need to have a play around with your calculator to make sure you can find your square root, your cube root, your squared, your cubed, your fraction button, your sin, your cos, your tan, and figuring these out. So I picked quite a complicated one here. So to get your cube root button, depending on what calculator you have, but the majority of them you still have to press the same things. We press shift and then we go for, let's get a different colour here, we go for the square root button, and that allows us to get a cube root. So on your calculator, a cube root will pop up, and then we're going to use the fraction button. So the fraction button is just next to it in this diagram here, the fraction button, and an empty fraction is going to pop up. So on the top, we're going to just type in on the top of that fraction there, 4.3 multiplied by, press your tan button, and then press 39, and normally this will go in a bracket, so remember to close the bracket off there. But you don't put this little degrees symbol in, you just put 39, the calculator knows that you're talking about degrees. So let's get that up on my calculator. We've got 4.3 multiplied by tan, the brackets opens for me, 39, close the brackets, press your down button on the calculator to go into the bottom of the fraction, and type this sum in here, 23.4 take away 6.06. So 23.4 take away 6.06, and make sure at this point you write all the numbers down. That equals 0.585593423. Now some calculators may go beyond this depending on what the answer is on the calculator, but it tends to be that you never really have to go beyond 9 digits, because not all calculators will go that far, so you are limited to the amount that some people will be able to write depending on what calculator they use. Now the question will probably usually say then to round your answer to 1 or 2 decimal places. So if we just have a quick think, if we were to round this to 1 dp, to 1 decimal place, and we could chop that after the 5 there. So 1 decimal place would round up to 0.6, and we would round that to 0.6. If we had this to 2 decimal places or beyond, let's have a think. After 2 decimal places, let's pick a different colour. It would chop it after the 8, and it would be 0.59 because it's a 5 after that one. Okay, so you could have different ways of rounding this, but just make sure you write down all the digits on your calculator display before actually rounding anything. In a store, you can buy 2 kilograms of washing powder for £3.40 or 5 kilograms of washing powder for £7.20. Which size is best value for money? Now, there's 2 ways of doing this. I always like to split the page up. So we've got 2 kilograms or we've got the 5 kilograms. Okay, and the 2 kilograms is £3.40 and the 5 kilograms is £7.20. Now we can either build this up to the same amount of kilograms for each, so we could think actually, well, what if we bought 10 kilograms of each? Well, that would be 5 of these would be 10 kilograms, so if we times £3.40 by 5, we get £17. Or we can have 2 of these, and that would be £14.40. And it's quite clear to see there that if we buy 10 kilograms of each, the 5 kilogram one is our cheaper option there. So we just make that statement, the 5 kilograms is cheaper. There is another way of doing this as well. So if we think along the lines of something easy, let's imagine 2 apples cost £1. So 2 apples equals £1. Well, to work out the cost of 1 apple, we would do the amount of apples divided by the cost. Sorry, the cost there divided by 2. So we would do £1, the cost, and we divide it by 2 apples. That will give us 50p per apple. And we can apply this same logic up here. So we can do the cost of each divided by the amount. So for the first one, looking at the 2 kilograms and £3.40, so we can do £3.40 divided by 2, and that gives us £1.70 per kilogram. Okay, per kilogram. We can also have a look at the next one in the same way, so £7.20. And we can do £7.20 divided by 5, and that gives us, let's have a look, £1.44. So £1.44 per kilogram. And again, you can see which one's cheaper there per kilogram. It's the £1.44, again, the 5 kilogram box. So 2 different ways, one non-calculator, one with a calculator, to work out a better value. Right, so 180 grams of copper is mixed with 105 grams of zinc to make an alloy. The density of copper is 9 grams per centimetre cubed, and the density of zinc is 7 grams per centimetre cubed. Work out the density of the alloy, which is just a mixture of metals. Now, whenever we've got this sort of mixture going on with mass, density and volume, I like to tidy it up in a 2-way table. First things first, we definitely need to make sure we write down our formula. So density equals mass over volume. Okay, and you can stick that into a formula triangle if you want, which I am going to do. So density, mass, volume. There we go. So drawing ourselves a little 2-way table to tidy this up. Let's have a look. Now for each thing we're going to need a density, we're going to need a mass, and we're going to need a volume. We have the copper, we have the zinc, and we have the alloy. I'm going to split this all up into a table. Right, so let's fill in what we've got. We've got a mass of the copper of 180. We've got a mass of the zinc of 105. It also gives us a density of the copper, which is 9, and a density of the zinc, which is 7. And it wants us to work out the density of the alloy just here. Now we can't add these densities together because the density is going to change as they're mixed together. So if one's 9 and one's 7, the density is going to be somewhere in between that. But what we can work out is the volume of the copper and the volume of the zinc. So looking at your formula, to get volume, we would do mass divided by density. So mass divided by density. So I'm going to do 180 divided by 9 for this one, which gives us a volume of 20. And for the zinc, I'm going to do 105 divided by 7. And 105 divided by 7 is 15. Now masses and volumes can be added together, so we can add these together. We've got 20 and 15, so 35 centimetre cubed is going to be the total volume of this alloy. And we can add masses together, so adding these two together as well. We can do 180 plus 105, which is 285 grams. And then we can finish this question off. It wants the density. Remembering density over here is mass over volume, so 285 divided by the volume, which is 35, and 285 divided by 35 gives us not a very nice number here, but we get 8.142857. It's actually a little recurring number there as well. Now this question would normally ask you to write that to 1 or 2 decimal places, so we would just round it however the question actually asks. But if it doesn't ask us, we write down the full number there, which is 8.14257 with those little recurring dots. David travels from Birmingham to Glasgow. He drives at an average speed of 70 miles an hour for the first 3 hours, and he then drives an extra or a further 150 miles at an average speed of 30. Work out his average speed from Birmingham to Glasgow, so for the whole journey. I'm going to take a similar approach as I did to the density question here, but I'm going to think about obviously using my formula now. So I want to write down my formula, which is speed equals distance over time, And again, we can put that into a formula triangle if we want, and I'm going to do that. So speed equals distance over time. So speed, distance, time. I'm going to use a little formula triangle. So let's see if we can tidy up what we've got here in a little two-way table. And again, for each one, we're going to need a speed, we're going to need a distance, and we're going to need a time. Now we've got the first part of the journey, the second part of the journey, and we've got the total journey. So let's split this all up and write in what we've got so far. Okay, so at the moment we have, he drives at an average speed of 70 miles an hour for the first 3 hours. So this first one here is 3 hours, and he drives at a speed of 70 miles an hour. The second part, it says he drives 150 miles, which is a distance, and he drives at an average speed of 30 miles an hour, so that's going to go just above there. And we want to work out essentially the average speed for the whole journey, which is this one just here. Now again, we can't join together speeds, it's going to be somewhere there in between the 70 and the 30. So let's have a look at what we can do. So this first distance here, let's see if we can work that out. So looking at our formula triangle, distance is speed times time. So we can do speed times time to work out that distance. So 70 times 3, the speed of 70 times 3, says it will go 210 miles. So again, we can add these together to get a total distance at the end there, because that'd be 360 miles in total that he's got to do. So all we've got to do is get this total speed here, this total time, and then we'll be able to work out his speed. So looking at this bottom one here, which is the time for the second one. So to get time, you do distance divided by speed. So distance divided by speed will be 150 divided by the speed of 30, which gives us a time there of 5. So that means in total he's going to be driving for 8 hours. Now we can work out his total speed, because we've got his total distance and his total time, and speed is distance over time, so it's 360 divided by the total time of 8 there, and 360 divided by 8 gives us an answer of 45 miles per hour. So I'll just write that down, 45 miles per hour. Again, keeping it all nice and tidy in a table so it all makes sense. Okay, so we're going to start by having a look at averages from a table. So this table shows the mark for 30 students in a test, and it wants us to calculate the mean and write down the modal mark. Now to calculate the mean, it's quite nice and simple. If we have a look at this table here, this first row says that there are 2 14s, and if we add together 2 14s we get 28, so we can just times these together to find out what the total is. So that's 28. 10 15s times those together is 150. 2 16s is 32. 3 17s, we'll have to work out, I think that's 51. 3 times 17 is 51. And the last one there is 13 times 18, so 13 18s is 234. Now if we add all this up, it'll tell us the total amount of marks that everybody got. So 234 plus 51 plus 32 plus 150 plus 28 gives us a total amount of marks there of 495. So that's their total, and it says that there are 30 students up here. Although if we didn't know that, we could add together this frequency column and we get a total of 30. So to find the mean, we just need to do 495, the total amount of marks, and divide it by 30. And that gives us a final answer there of 16.5. And don't forget, your answer has to fall in between the range here, which is between 14 and 18. So 16.5 is within that, it makes sense, we're happy with that. Now part B says to find the modal mark. Now the modal mark just means the mode mark, okay, the one that's the most common. And if we have a look at our table here, the one that's the most common is this one down at 13, and that represents 18 as the modal mark. So the modal mark would be 18, okay, because 13 people got that, and that's the highest there in that frequency table, so 18. Now this question is very similar. It shows the height of 30 students. This is calculating an estimate for the mean, and then again write down the modal class interval. So the reason it says to find an estimate for the mean is because we can't get an exact mean, because we don't actually know, particularly looking at just this first row, what that person's height actually is. It's one person between 130 and 140. There could be anything, 132, 138, anything in between. So what we do is we pick the midpoint. So in between 130 and 140 is 135, and we're just going to use that as an estimate for the height of that person. And we'll do the same for all the others, 145, 155, 165 and 175. And we'll just treat this in exactly the same way as we did before. So one person at 135, 7 people at 145, and we're just going to times across for all of these again. So one lot of 135 is 135, 7 lots of 145 is 1015. Again, I'm just doing this on the calculator. 8 times 155 is 1240. 10 times 165 we can do 1650, and 4 times 175 gives us 700.
And again, from here, it's just the same process. We add those all together. So 700 plus 1,650 plus 1,240 plus 1,015 plus 135 gives us a total there of 4,740. And again, it said that there were 30 students there, which we can find from the bottom. So finishing the sum exactly the same as before, 4,740 divided by 30 will give us an estimate here for the mean, because again we have just guessed what their heights are as using those midpoints, which gives us 158. And again, that answer there has to fall in between this range here, which starts at 130 there and ends down here at 180. So it has to fall in between, so 158 centimetres. Now the next bit says write down the modal class interval. Now the word class just means group, so it's the modal group, which group is the most common, and that's here with these 10 people. So all I have to do is, and I've written over the top of it now, but all I have to do is write this group down here. So the modal interval, okay, is that exact thing there, and I just write it down word for word, 160 to, what was in the middle, h in this instance, to 170. And that would be my modal class interval just there. So when we're looking at circles, there's two formulas that we need to know. Circumference equals pi times diameter, and area equals pi r squared. Remember the units for area have squared in, don't they? When we use centimetres, we have centimetre squared. So I always like to remember the little formula for area there is the pi r squared, the one with the squared in. So we're going to work out the area and the circumference of this circle. So to work out the area, we're going to do pi r squared if we start with that. So the area equals pi r squared, and we just need to know what the radius is. So over here the diameter is 8, so we're going to first halve that for the radius, so I'll just write r equals 4, and we've just got to type that in. So pi times 4 squared. 4 squared is 16, so it'd be pi times 16, and you can just write that as 16 pi. So if it asks you to give your answer in terms of pi, you can just do that, but we want to type that into our calculator if not. So 16 times pi will give us a decimal, which is 50. I'm going to round this, but obviously only round it if it says to in the question. It'd be 50.27 if I round it, centimetres squared, and that'd be an area there to 2 decimal places. Let's have a look at working out the circumference. So circumference up here is pi times diameter. Now we've been given the diameter is 8, so to get the circumference, we just do pi times 8, and we could just say 8 pi. So we could just say 8 pi, which just means pi times 8. But again, if it asks us to work it out, we're going to do pi times 8 on the calculator. So 8 pi, press equals, and we get, and if I round this to 1 decimal place this time, I get 25.1. And circumference is a distance, it's around the outside, so it's just centimetres, 25.1 centimetres. But again, rounding it to how the question asks, and remembering you can write it in terms of pi, like down here 16 pi, and up here 8 pi as well. Okay, so working out the area of a circle sector. Now we're going to do this in a very similar way to what we did with the circle. We're still going to do area equals pi r squared, but because it's a fraction of a normal circle, we're going to times it by whatever fraction of the circle that is. So it says over here it's 102 degrees, so it's 102 degrees out of a normal 360 degree circle. So we're going to plug the numbers into there and we'll get our area. So it says down here the radius is 8, which is quite nice, so it's pi times 8 squared multiplied by this fraction of the circle, 102 over 360. You can type that into the calculator, so pi times 8 squared times 102 over 360, and that gives us an area here of 56.96754679, and I tell you what, let's round it to 2 decimal places, so that would be 56.97, and again units, centimetre squared. And there's the area of the sector. Again, you could actually work out this here as well if you're asked to. It's called the arc length. So we would do the same thing, but we'd use our circumference formula. So we'd do the circumference equals pi times diameter multiplied by the fraction there, which would be 102 over 360. So we could work out both just using the appropriate formula in the same way. That same logic can be applied to a cylinder. So our cross section this time is a circle. So all we've got to do is work out the area of the circle, remembering area equals pi r squared. So working out the area of that circle, it's pi times 4 squared, which again is 16 pi. We can write that as a decimal. Now what I'm going to do is I'm just going to leave it as 16 pi for the moment, so I don't have any rounding errors here, but you can write it as a decimal at this point, but I'm just going to leave it as 16 pi. Now once you've got the area of the cross section, you just times it by how far it goes through the shape, which in this case is this 15. So all I've got to do is times that by 15. So 16 pi times 15, which comes out as 240 pi, which is also a decimal, so it just depends on how the question wants the answer here. So it's 240 pi, or if I write that as a decimal, remember that S to D button or F to D button on your calculator, depending on which one you have, you get 753. I'm going to round it to two decimal places again, 0.98 centimetres cubed for volume, and there's the volume of my cylinder. So surface area of a cylinder is a little bit more complicated because we've got these two circles to work out, and then we've got this shape wrapped around the outside of the cylinder. So the area of the circle we've actually already worked out. Pi times r squared is 16 pi, and that equals the circle. Okay, and not forgetting we've got two of those, so let's times that by 2, which gives us 32 pi, which again is a number, but I'm just going to leave it till the end for the area of my two circles. Now the next thing that I have is this shape wrapped around the outside, and if we were to unravel that, we'd have a nice big rectangle, and the height of that rectangle there is 15. The length of the rectangle is actually the circumference of the circle. So we just looked at circumference of a circle. The circumference is pi times diameter. So I'll do 8 times pi, or 8 pi, the diameter there being 8. It's given us a radius of 4, so we could put the diameter equals 8. But that's 8 pi for the length. And we work out the area of a rectangle just by doing length times width. So to work out the area of this, we'll do 15 times the 8 pi. And that gives us 120 pi for the area of that rectangular part wrapped around the outside. All we've got to do to finish this off is add these two together. So we have 32 pi, add 120 pi, and in total that gives us 152 pi. Again, we could just write this as a decimal, but 152 pi comes out as 477.5 to one decimal place centimetres squared for surface area, and there's our final answer. So you just got to remember, you obviously got the circles top and bottom, and then to work out the area of the curved part, you need to think about that circumference there being the length of the rectangle. Okay, so starting this off, we're having a look at working out the length AB. I've got two different triangles here, two different questions, so let's identify where AB is on the first one. So A to B is this length here. Now when it comes to right-angled triangles, if we've got no angles involved, we can use Pythagoras to work out the missing lengths. So Pythagoras Theorem is A squared plus B squared equals C squared. Now that C represents this longest length here, which we call the hypotenuse, so this is the hypotenuse. So I'll label as HYP, so the hypotenuse, and we've got the shorter sides A and B, so 4 and 7. So to work out this length of this hypotenuse, we're going to do 4 squared, add 7 squared, and work that out on the calculator. So 4 squared plus 7 squared is 65. Now that is obviously the length of C squared, so to find out what C is, we just need to square root our answer. So to finish that off, square root of 65, which gives us a decimal for this particular answer, and that gives us a length of 8.06225 and some more decimals. And again, if it asked us to round it to 1 or 2 decimal places, we'd do that in the question. Now moving on to the next one, we've actually got the length of the hypotenuse this time, so we've got 13. And we're trying to find out this length this time, so A to B this time is one of the shorter sides. So rather than add them together like we did down here, we're just going to subtract them. So we're going to do 13 squared, take away this shorter side, which is 12 squared, and again we're going to square root our answer. This is quite a good one because it's actually one that could be done without a calculator. We get 169 for 13 squared, take away 144, and 169 take away 144 is 25. Okay, so as you can see, that's given us a square number. So when we finish this question off, to do the square root of 25, we get the answer 5. This is all in centimetres, so that'd be 5 centimetres. So over here our answer would be 5 centimetres. Okay, so Pythagoras, square the sides, add them together before square rooting for the longest side, and subtract them for one of the shorter sides before square rooting. Okay, so looking at trigonometry. Now the hint that we're going to be using trigonometry is we've got a right angled triangle and there's an angle within them. So looking at this one on the left to start with, because we're going to work out the missing length in these two triangles, I'm going to start with this one on the left. So we've got an angle of 43, and the only thing I have to remember here is how to spell Sohcahtoa. So S-O-H-C-A-H-T-O-A. There we go. Now that's just going to help me to know which I'm going to use, whether I'm going to use sin, cos or tan. So the first thing I need to do is I need to label this triangle to see what sides we've got. So opposite the angle that we're using, that's called the opposite. The longest side, which is opposite the right angle, is always called the hypotenuse, and the final side there is called the adjacent. Now there's one of the sides here I don't need to be thinking about. I need to use the opposite. I'm looking for the hypotenuse, so I don't need the adjacent. So let's have a look at what formula triangle we're going to use. Well, O and H, opposite and hypotenuse, is within my sine triangle there, SOH. We've got O and H within that triangle, so I'm going to use SOHCAHTOA. The part of SOHCAHTOA I'm going to use is sine. Now the side that I'm looking for is the hypotenuse up here with the x next to it. So hopefully you're used to using formula triangles. I'm going to cover up the h. Okay, so the sum that I need to do to find the hypotenuse is O over S, or O divided by S. So that's O divided by sine. So to find the hypotenuse, I'm going to do the opposite, which is 6, and I'm going to divide it by sine. All I need to remember is to put the angle here, 43, with sine. So sine 43. So sine 43 tells me the relationship between the opposite and hypotenuse, and in this case we're going to do a divide. O on the top, S on the bottom. Don't forget to put 43 in the bracket there for some of your calculators. So 6 divided by sine 43 on the calculator, 6 over sine 43 is 8.79 centimetres. I'm going to round that to 2 decimal places, and it actually comes out as, if I write a few down, it's 8.7976. The question will tell you how to round it. So if I round it to 2 decimal places, that would be 8.8 actually, 8.8 or 8.80. Let's round it to 1 decimal place. So we've got 8.8 centimetres for that first question. Now if we have a look at the one on the right, so question 2, we've got a very similar process here. Let's have a look. So we still have a look at our angle, label the sides, so opposite that is our opposite. And then we've got the hypotenuse here. And again, the adjacent ends up being down the bottom based on where that angle is. Now again, we need the opposite because that's the one we're looking for. We need the hypotenuse because that's given to us, but we don't need the adjacent again. So again, I'm going to be using my sine triangle because I've got O and H. I'm going to rewrite it again. So I've got SOH, but this time we are looking for the opposite. So I'm going to do the same process again. I'm going to cross off the opposite, and that tells me that I'm going to do a times. I'm going to do S times H. Now S again stands for sine. I just need to put the angle with it. So this time it's 36. So sine 36, making sure you put it in a bracket again, times by the hypotenuse, which is here, which is 9. So sine 36 times 9. And again, typing that into a calculator, sine 36 times 9 gives me an answer of 5 point, and if I round it to 1 decimal place again, well, it comes out as 5.29. So to 1 decimal place, that would be 5.3 centimetres. And again, just thinking logically here about whether your answer makes sense, because it can't be longer than the hypotenuse there, so it can't be longer than 9. So you should know if you've done it wrong, because it might end up coming out longer than 9. So that's finding side lengths using SOHCAHTOA. When it comes to finding an angle, we've got a very similar process. I'm going to have a look at this question. It says find the sides of angle ABC. So from A to B to C, that gives us this angle down here. And again, I'm going to follow the same process. So opposite that angle is over here. Our hypotenuse is opposite the right angle, and our adjacent side is down here. So it looks like I've got a different bit of SOHCAHTOA to use this time, because this time I don't need the opposite, but I do need the hypotenuse and the adjacent. So again, just write down SOHCAHTOA. And we're looking for the formula triangle, this time that has the H and the A in, the hypotenuse and the adjacent. So the H and the A is in my cos triangle, so I'm going to be using this one. Now we're looking for the angle this time, so if I cover up the angle part, which is the C, it tells me that I need to do A over H. Now if we just do that, A is 7 and H is 13. Now if I just type that into the calculator, 7 divided by 13 just gives me a decimal 0.538. Now the calculator doesn't know that this time I'm looking for an angle, so all I'm going to do to tell the calculator I'm looking for an angle is first I'm going to press shift and then press cos. So shift cos. And on your calculator it will come up with, and let's get it on my calculator here, you get it saying cos -1, and that just tells your calculator this time I'm looking for the angle and this is the fraction I want to put in. So you type in cos -1 and then 7 over 13, and if your calculator has the fraction function you can put it in as a fraction. If not, in the bracket there just put 7 divided by 13. So let's do that. Cos minus 1, 7 divided by 13, or 7 over 13 is a fraction, and you get the answer here, 57.42. And if we round that to one decimal place, it'd be 57.4 degrees. There we go, for an angle. So it's the same process no matter which formula triangle you use. You just have to identify the sides, and then when you're looking for an angle, you're always going to press shift cos, shift sine, or shift tan, and you'll get this little symbol here, cos minus 1. Next one here, we have a hemisphere, and it says work out the volume of the hemisphere. Now again, we'd be given the formula to work out the volume of a hemisphere, and volume of a hemisphere is 4/3 pi r cubed. And that is our final volume there. Oh, let's make sure that says, that's a rubbish 3. Let's change that. 4/3 pi r cubed. So all you've got to do is stick the numbers in the formula again. So if I want to work out the volume, all I have to do is in the calculator, I do 4/3 multiplied by pi multiplied by 8 cubed, and we'll get our answer here straight away. So fraction button, 4/3 multiplied by pi multiplied by 8 to the power of 3. And we get a volume here of 2144.66, again if I round it to 2 decimal places, centimetres cubed. Just remember obviously to write all the numbers down and only round it once you've been asked to. Okay, so once you've got your total volume of your sphere there, just remember this is a hemisphere, so it's half the size of a sphere, exactly half. So I just need to divide my answer by 2 here. And once we divide that by 2, we get a final answer of, let's have a look, 1072, so 1072.33. Again, I've rounded it there, centimetres cubed. And that would be your final answer here for the volume of a hemisphere. Not forgetting as well, you could be asked to work out the surface area. And if you're asked to work out the surface area, again, it gives you the formula of a sphere. And the surface area of a sphere is 4 pi r squared. So again, if I was to work out the surface area of this one, it's a little bit more complicated, but only in the sense that we work out the full surface area. So we do 4 times pi times 8 squared. If I just go for this, let's work it out. 4 times pi times 8 squared. That gives us a surface area of a sphere being 804, and it's 0.25 as well. Again, we'd have to halve it because it's half. Okay, so half of that would give us a surface area of 402.12, and that is obviously a surface area, so it's centimetres squared. But if you're working out surface area, you've got to make sure you don't forget as well the circle sitting on top there, because it's the total surface, and the area of a circle is pi r squared. So we can work out the area of the circle as well. And if we just do that, pi times 8 squared, we get an area of the circle there of 201.06, and you would just add these two numbers together to get the total surface area. So if you add 201.06, we get a total surface area of 102.12 added to that, gives us 603.18 centimetres squared. Again, so I know we were looking at volume there, but just thinking about if you had to do the surface area as well, how you'd approach that when you've got a hemisphere and you've got to make sure you halve them and add on the extra circle. So it says there are 20 men, 20 women and 10 children, and they take part in a quiz. And then it gives us the mean score for the men, the mean for the children, and the mean for the whole group. And it wants us to work out the mean score for the women. So that's what we want to work out eventually. So all we got to do is think in reverse for this. So when you're working out the mean, you get the total and you divide by how many people there are. So if we think about the men, you don't have to write it like this, but just so you have an understanding of this, you would get the total, which we don't know. You divide it by the 20 men, and it says it gives us an answer of 6, the mean for the men. So if we reverse this round, times both sides by 20, so times by 20 gives us a score of 120 for the men. So that's the total score for the men. We could then do exactly the same for the children. I don't have to write out this little bit of algebra every time, but if I just think, okay, well the children then, I just know I need to times the amount of children by the mean. The mean is 4, and there are 10 children. So 10 times 4 gives us a total score of 40 for the children. There we go. Now we don't actually know what the mean is for the women, that's what we're trying to work out, but what we are given is this last bit of information here, which says the mean for all of them is 5. Now in total, if we have a look at the question, it says there are 20 men, 20 women and 10 children. So that's 50 people with a mean of 5. So that we could do 50 people times the mean, which is 5. which gives us a total score of 250. So that's our total there. So now we know the total score, we know the score for the men, we know the score for the children, so we can actually work out what score the women got. So if we do this to the side, we know we have to do 250, take away the 120 that the men got, and take away the 40 that the children got. And if we work that out, 250 take away 120 is 130, take away the 40 leaves us with a total score of 90 for the women. So the women scored a total of 90, and it says that there are 20 women. So to work out the mean for them, we've got 90 is their total score divided by 20. And again, depends whether you have a calculator or not here, but even if you don't have a calculator, we can do this one. We can cancel off the 0 top and bottom, and it's 9 over 2, or 9 divided by 2, which is 4.5. There we go. So the women have a mean of 4.5, and that'll be our final answer there to finish that off. There we go, and that's our little bit of statistics done. So write 180 as a product of prime factors and give your answer in index form. So we can do our nice little prime factor tree. And again, thinking of any two numbers that times to make 180. So I'm going to go for 18 and 10. 10 becomes 2 and 5, locking off those numbers when we see that they're prime. 18 is 2 and 9, and 9 is 3 and 3. And again, locking those all off when they're prime. Remembering you can write down some of the prime numbers if it helps. Now writing these in size order, we get 2 times 2 times 3 times 3 times 5, and then we can simplify these. So 2 times 2 becomes 2 squared, 3 times 3 becomes times 3 squared, and then times 5 at the end, and that's in index form there using indices. Okay, so there are 15 pencils in a pack and 40 pens in a box. How many packs of pencils and boxes of pens would we need to buy to have the same amount of each? So we're looking at lowest common multiple, so 15 and 40. I'm going to do a list of their times tables, so 15, 30, 45, 60, 75, 90, 105, 120. And there it is. I know that 40, 80, 120, that's going to be our lowest common multiple there. So the question said how many packs of each? So that is one on the top. We've got 1, 2, 3, 4, 5, 6, 7, 8. That was the pencils. So that's 8 packs of pencils. 8 packs of pencils. And below there we have 1, 2, 3 boxes of pens. Okay, so just remember to read the question there, what's it actually asking for in the final step, even though we were looking at lowest common multiple for that one. Let's have a look at the next one. So find the highest common factor of 72 and 90. So we've got different methods of doing this. We can write down 72, we can write down 90 and start finding all their factors. We can of course use the prime factor method, but let's have a look. Let's start with 90. 1 and 90, 2 and 45, 3 and 30. Let's see what else goes in. 4 doesn't go in, 5 does. 5 goes in 18 times. 6 goes in, let's have a think, 15 times. 7 doesn't, 8 doesn't, 9 does, 9 and 10. Now the numbers are right next to each other, so there's no more to look at. So starting with the biggest, let's have a look which one goes in. 90 doesn't, 45 doesn't, 30 doesn't go into 72, does 18. 18 actually goes in 4 times. So 4 times 18, we don't have to do all the factors of 72 there because we've spotted that it's 18. Of course we could use the prime factor method to find the highest common factor, which I'd recommend for numbers like this, so 72 and 90. Do their prime factors, so 8 and 9, 3 and 3, 2 and 4, 2 and 2. 90 is 9 and 10. And then we have 3, 3, 2 and 5. And we can have a look at what's in both. So they both have a 2. They both have a 3, so times 3. They both have another 3, and that's all that they share. 2 times 3 is 6, times 3 again is 18. So we can get our highest common factor using our prime factor method as well. Okay, so on the number line, show this inequality. So when we're drawing these sorts of things on a number line, we look at what numbers we've got. We're going to put our little circles above those, so -2 and 4. And we're going to join them up. And then we just need to have a look at these symbols. So the one here, which is less than or equal to, or pointing towards that less than or equal to, it has more ink on it, so we just remember to colour that one in. Make sure the circle has more ink in there as well. Nice little way of remembering it. There we go. So that is between -2 and 4. Remembering that is equal to -2. So the numbers that this could be is we could have -2, -1, 0, 1, 2, and 3, but not including the 4 there because it says less than 4. So you can have an inequality like this as well, where it just says x is greater than or equal to 1. So again, putting our circle above the 1, the greater than or equal to has the extra ink on it, so we'll colour that one in. It's equal to that as well, and greater than 1, so we'll just point an arrow to the right saying it's got to be greater than 1. And that's that for that type of inequality. Right, so a washing machine costs £640 plus 20% VAT. James pays a £68 deposit and the rest in 10 equal monthly instalments. Work out the cost of each monthly payment. So it's a percentage of an amount question, so we need to work out 20% of 640. 10% is the most important percentage we ever have to work out, so we can work out everything from there. So we'll work out 10%. 10% is £64. 20% will be double that. So double that is £128, so that's the extra amount he's got to pay for VAT. So if we add these together, 640, add 128, we get £768. Now it says he's going to pay a £68 deposit, so let's take that £68 off because that's what he pays right at the start, and that leaves us with £700. Now it says in the question he's going to pay that in 10 equal monthly instalments. So if we finish this off, if we divide this by 10, so 700 divided by 10 tells us that he's going to pay £70 per month. There you go. So the main part here was the working out the percentage. So always work out 10%, and remember from there you can figure out any percentage. We could have halved 10%, we could have got 5% as 32, or we could have actually divided it by 10, we could have got 1%. Dividing 64 by 10, 1% would have been £6.40, and we could have built that up to any percentage that we wanted from there, so £6.40. Let's have a look at something else. Okay, so a mobile phone is reduced by 20% in a sale. The sale price is £500, work out the original price. So this is a reverse percentage. It's asking us to work out the price in the past. Now I like to draw this in a slightly different way. I want to identify what percentage is this 500. So if it's been reduced by 20% in a sale, well, that means that we have the 80% of the cost and this 20% reduction, if I think of this in terms of two little bars. So I've just got to think, which percentage actually is this 500? Is it the 80% or is it the 20%? Well, the sale price is the amount that we're paying, so not the little 20% sale. So that £500 equals 80%, and I always like to write this down. Now we don't want to know what 80% is, we want to know what 100% is. So I just need to think, how do I actually turn this back into 100%? So if we've got a calculator, this is nice and easy because we can divide that by 80, which will give us 1%. And if we do that on a calculator, 500 divided by 80 gives us £6.25. Okay, so 500 divided by 80. So if we have a calculator, we can do that. We can do 500 divided by 80. That tells us 1% is £6.25, and then we can times that by 100 to get 100%, and that would be 100% of what we're looking for equals £625. Oh, that's not a 6, £625. Okay, if we don't have a calculator though, we're going to have to think of a different way of doing this. So what we can do is think about actually just dividing this by something to maybe get 10%, and you can divide 80 by 8 to get 10%. So if we divide 500 by 8, we'll also get 10%, and we can do that using a bit of a stop. So off to the side, if we didn't have a calculator, 8 into 500, 8 into 50 goes 48. So it would go in 6 times up to 48 with a remainder of 2. It would go into 20 twice up to 16 with a remainder of 4, so we'd have to carry that over. And then 8 goes into 45 times, so we get that 62.5 as 10%. So 10% is 62.5. And then we can times that by 10 to get back to 100%. And 100% there would be £625. So we get there either way, but that's two different ways of looking at a reverse percentage where we're looking for something in the past when there's a sale going on. Okay, so the other way around, a house rises in value by 3%. The value of the house increases by 7,500. Work out the value of the house before the increase. So when it's been increased in value, again, we can visualise this. We've got the original price, which is our 100%, and then it's rising in value by this extra little 3%. So again, identifying what is this 7,500? Is it the original 100% or is it the 3%? Now it says it rises, it increases by 7,500. So that 7,500 is my 3%. There you go, and again we want to know 100%. I can't straight away times 3 to get to 100, but I can divide both of these by 3 to find out what 1% is. And again, we can do that on a calculator or using better bus stop, but 7,500 divided by 3
is 2,500. So 2,500 equals 1. And again, we can times that by 100. So over here, if 1% equals 2,500, we can times that by 100 to get our 100%. So 100% will equal 2,500 with another 2 zeros, and that's 250,000. So our answer there would be £250,000. So £800 is invested for 2 years, offering a 1.5% simple interest rate per annum per year. How much is in the account after 2 years? Now, simple interest means it doesn't keep accumulating. So if we first work out what 1.5% is, again, if you haven't got a calculator, we can do this non-calculator. So 10% of 800 would be 80. 1% would therefore be 8, and 0.5%, which we're going to need there, is 4. So joining those two together, the 1 and the 1.5 gives us 12. So we get £12 there for our 1.5%. Now we can do this using a calculator as well, which I'll discuss in a sec, but if we're going to get £12 per year, simple interest just means that's what we're going to get per year. So if it's 2 years, we'll times that by 2, and we will get £24. So that's the amount of interest we'll earn. It does say how much is in the account though, so if we add that back into the account, we'd have £824 as our final answer. Now if you've got a calculator here, you can always use a multiplier method. So we could do 800 and we could times it by 1.015, and that gives us the answer 812, telling us that in that first year there we've earned £12 interest. So adding in another 12, so add another 12 would give us 824, the same answer. Okay, or you could times it by 0.015, and that would have just straight up given you the 12, and you can add that on for how many years for simple interest. So Mary buys a car for £4,000. Each year it depreciates by 20%. Work out the value of the car in 3 years. So that word depreciate means it falls in value. Now again, with depreciation, it's similar to compound interest. It falls in value, but it falls in value based on its new price. So if we do this without a calculator, we can do it both ways. Year 1, the £4,000 is what it's worth. 20% of that we can work out. 10% is 400. 20% is 800. And if we take away that 800 there, so 4,000, take away 800, we end up with 3,200. So we don't keep losing £800 a year. Now in the second year, it's worth 3,200. 10% of that is 320. 20% of that is double that, 640. And we could subtract 640. So 3,200 take away 640. Will leave us with our answer for the final year. Take away 640 there, gives us 2,560. And we can finish this off, or I should have said year 2, we can finish this off on year 3. So our value is 2,560. 10% of that is 256. So 20% will be 512, and then we can subtract 512. So 2,560 take away 512 leaves us with a final value there of 2,048. £2,048, and that'd be our final answer. Again, we could do this with a calculator. If something loses 20% in value, then it's only actually worth 80% of its cost the previous year. So if it's worth 80%, the decimal that I can use for 80% is 0.8. If it's losing value, we won't want a 1 point number there, we've got 0.8. So we could just times it by 0.8 3 times, or times it by 0.8 to the power of 3. So I could just type into my calculator 4,000 times 0.8 to the power of 3, and I'll get that answer there, 2,048 as my final answer. And let's test that out. 4,000 times 0.8 to the power of 3, and we get 2,048. So that's depreciation. Okay, some error intervals. 6.4 has been rounded to 1 decimal place, and write the error interval. So the error interval, we always tend to put either 6.4 or a letter in the middle, depending on what the question is, and we have our arrows always pointing to the left. So we're going to find the upper and lower bound. Now 6.4, if it's been rounded to 1 decimal place, it couldn't have been 6.45.
5. As soon as that 5 goes after that 4, it would have rounded up to 6.5. So we put that on the right hand side as our biggest possible number that it couldn't have been 6.45. So it can't be equal to that number, so we leave that symbol as it is. It's got to be less than 6.45. Now what we did there is we added on this extra 0.05, and all we're going to do for the smaller one is take that away. So it would be 6.35. Okay, but it can actually be equal to 6.35, so I'm going to add my little equal to symbol on my inequality just there. So it can always be equal to that lower bound, because that would in fact round up to 6.4 if we rounded it to one decimal place. On to the next one. This one's slightly different in the wording. So this one says it's been truncated to one decimal place, and truncated basically just means it's been chopped off at that after this first decimal, regardless of how it rounded. So if we have a look at writing this as an error interval, again we write these in the same way. The impossible number that it couldn't have been 6.5. So my top one here is 6.5. It had to be 6.4 something if it was just chopped off. Let's imagine just a random how this works. So it could have been 6.4932, but it was just chopped here and we just wrote what was at the start. Okay, but it couldn't have possibly been 6.5 because otherwise we'd have written 6.5. And the smallest it could have been is just 6.4 with no digits after it. It couldn't have been 6.3 though, because again, if we truncate that, it would have just been 6.3. So two different scenarios there. One where you've got to add on that extra 5 at the end and take the same size 5 off the start, and truncating there where we've just got to think about the fact that it was just chopped off and no rounding at all. Okay, so moving on to algebra, and we're looking at index laws to start with. So we know with index laws, we've looked at this when we have powers that are getting multiplied together when they have the same base number. These powers can be added together, so 2 and 3 would make 5. We also had the process when they're being divided. So x to the power of 7 divided by x squared, we take away the powers and we get x to the power of 5. And we also have powers in brackets, so if we have x squared to the power of 5, we multiply the powers, so we get x to the power of 10 in that particular example. Now having a look at this one, we've got 30x squared y to the power of 3 on the top and 6xy squared on the bottom. So we're doing a divide. Now we've got these numbers on the top and the bottom, 30 on the top, 6 on the bottom. So numbers always just divide numbers, so 30 divided by 6 gives us 5. Now individually looking at the letters, we've got an x squared, and on the bottom we've got an x. Now it's not written in there, but that is a little power of 1 there that's not written. So if we subtract the powers, 2 take away 1 gives us x to the power of 1. I'm not going to write that in, I'm just going to leave it as x because that means x to the power of 1. Moving on to the y's, we have y to the power of 3, y squared on the bottom, and 3 take away 2 gives us just y on the bottom there. So our final answer would be 5xy. Okay. Looking at this one then, we've got powers in brackets, so we're going to be multiplying powers here. But we've got this number 2 in the start as well, so numbers always get treated like numbers, and that whole thing is being cubed. So we need to work out what 2 cubed is. 2 cubed is 2 times 2 times 2, which is 8. So we're going to have 8 at the start of this one. Multiplying the powers for the x then, x to the power of 2, that's going to get times by 3, so that's going to become x to the power of 6. And y there is a power of 1 which is not written, so 1 times 3 gives us y to the power of 3. And there's our final answer there. On to expanding brackets. This first bracket we are multiplying everything inside the bracket by b. So b times 3b, well not forgetting there's a 1 in front of that, 1 times 3 is 3, and b times b is b squared. On to the next one, 1b times 7, well 1 times 7 is 7, and there's just that 1b that we're going to leave in there, and we're just going to copy that symbol, which is a plus, so keeping that as a plus. On to expanding below, we have 3y times 5. 3 times 5 is 15, and we've got the 1y there, so we'll leave that as a y. And then 3y times the 4y, well 3 times 4 is 12, y times y is y squared, and then again copying that symbol as a negative. Expanding and simplifying two brackets, so we'll expand these separately, so let's have a look at the first one. So 3 times 5 is 15, and 3 times 4 is 12. So we have 15x plus 12. On to the next one. Got to be careful with this one because it's saying take away, which means this is a negative 2 at the start of the bracket. So we're going to times both these pieces by negative 2. So negative 2 times 3x is negative 6x. And negative 2 times negative 2 gives us positive or plus 4. Now we just need to tidy all this up, so we have a 15x take away a 6x, and that gives us 9x's in total. And we have a 12 add a 4, and 12 add 4 is 16, that's positive 16, so we get 9x plus 16. Moving over to expanding and simplifying a double bracket. So x times x gives us x squared, x times negative 5 gives us negative 5x, 3 times x is positive 3x, and then positive 3 times negative 5 is negative 15. And then again, we just need to tidy this up because we've got these two x pieces in the middle. So we've got x squared still at the start, but we've got negative 5x add 3x, which in total is negative 2x, negative 5 add 3, and then we've got the negative 15 at the end. Onto the one below. So we've got some numbers in front of the x's here, so I'm going to do the same process. Let's see if we can move some of this out of the way. Just about. Okay, so 2x times 3x, 2 times 3 is 6, x times x is x squared, so we'll get 6x squared. 2x times 4 is 8x, that's negative 4, so it's negative 8x. Negative 3 times 3x is, well, 3 times 3 is 9, so negative 9x. And then negative 3 times negative 4 will give us positive 12. 3 times 4 is 12, and it's a negative times a negative. And then again, just tidying this up, we have 6x squared at the start, and we've got negative 8 take away another 9x. So negative 8 take away another 9x is negative 17x. And then we've got that plus 12 at the end, and there's our final answer. And we've simplified it there with the simplifying in the middle. Final answer. Okay, so factorising. We're going to take out a factor and put this into brackets. So we have a look at both these pieces, 3x and 15. We just think what number goes into both of those. They both divide by 3. So we're going to divide this by 3. So 3 on the outside of the bracket, that's the factor we're taking out. 3x divided by 3 is just x. Copy the symbol with a plus, and 15 divided by 3 is 5. And you can check your answer there. You can expand that back out just to check that you do get 3x plus 15. Now this next one says factorise fully, and that's because there's more than just one thing that comes out of the bracket in this one. So in that one above there was just a 3 that came out. So here we're going to have two things, and let's have a look at both these pieces. So we've got 35x and 21x squared. So they both have an x in, so there's definitely going to be an x coming out. Just need to think with 35 and 21, what's the biggest number that goes into both of those? That is 7. So the highest common factor of those two numbers is 7. They also both have an x in, so we can take x out as well and then follow the same process. So 35x divided by 7x, or what do we times 7x by to get 35x? Well, we have to times 7x by 5, but we don't want to put an x in there because we don't want to make that go up to an x squared. Copy the symbol. We times 7 by 3 to get 21, but we want that to be an x squared, so I'm going to stick another x in there with it. That would enable us to get an x squared when we expand that, and there's our final answer, factorised fully. Just a note, if you didn't take the 7x out and you just took a 7 out, for example, and this wouldn't be factorised fully, you'd have got 7 brackets 5x minus 3x squared. And you can see in that bracket there, there's still an x in both these pieces. There's a little hint there that you didn't fully factorise it. Okay, so on to factorising a quadratic. This is the opposite of expanding a double bracket, so we know what our answer is going to look like already. It's going to be in a double bracket, both with an x at the start. Now when we're doing this, we've just got to find the pair of numbers that are going to go into our bracket. So looking at the 12, we know it's going to be a pair of numbers that multiply to make 12. So I always write these down. We can have 1 and 12, 2 and 6, or 3 and 4. We just need to have a look at these numbers there because we've got a 7x in the middle, so they have to add up to make 7x. So 1 and 12, there's no way I can make 7. 2 and 6, I could either make 8 by adding them together, or I could make 4 or minus 4 if I do a minus with one of them. So I'm not going to make 7, but I can make it with 3 and 4. I can have plus 3 and plus 4, and that would make 7. So plus 3 and plus 4, and that's not a 4, plus 3 and plus 4, and that would be factorised. Having a look at the one below, we've got some negative symbols going on there, so we've got a slightly different process, but our answer is going to look the same. It's still going to be in a double bracket, it's still going to be x at the start, and we're still going to have two numbers in here with some symbols. So 28, the numbers at times to make 28 are 1 and 28, 2 and 14, or what else could we have? 4 and 7, and let's have a look if these can make 28. So what have we got? We've got minus 3 in the middle. So we want to make minus 3. Well, we're not going to do that with 1 and 28. That's not going to work. 2 and 14, we could make 16 or we could make 12. That's not going to work. But 4 and 7, we could do plus 4, take away 7. That would make minus 3. So plus 4 and negative 7. And that's our double bracket there finished.
So on to solving equations. So when we've got this word solve, it means it wants us to find the value of this x piece just here. So we've just got to reverse the process of what's going on. So at the moment it says 3 times the number, 3 times x plus 5 is 26. Well, if we get rid of this plus 5 by taking away 5 from both sides, that tells us that 3 times the number, 3x, must equal 21. And that means 3 times the number, so we can reverse this process now by dividing by 3, which I like to write as a little fraction, so divide by 3. And 21 divided by 3 is 7, so we would write x equals 7, and there's our final answer. So have a look at this next one. So 5x minus 2 equals 21. Well, this time to reverse this, we've got 5 times the number, take away 2, so if we add the 2 onto both sides, we get 5x equals 23. And here comes the part where I explain why I like to write it as a fraction as above rather than just write and divide by 3, because in this circumstance 23 doesn't divide perfectly by 5. So if we go divide by 5 again and divide by 5, we have our answer there written for us, 23 over 5. So x equals 23 over 5. Okay, which we could convert back into a mixed number. 5 goes in 4 times with the remainder of 3. So we could write it's 4 with that remainder of 3/5 there. Or I could even write it as a decimal. I could type that into my calculator and turn it into a decimal, but it's fine to leave it as a fraction. 4 3/5 is my answer. So here's one we've got x on both sides of the equation. So in order to make this look like one of the equations from before, we want to get rid of x from one of the sides. Now it doesn't matter which one we choose. I always choose to go for the smallest x. So we've got a 5x on one side and a 3x on the other side. So 3 being the smaller one. So we can take away 3x from both sides. That's smaller x. So if we take away 3x from both sides, well 5x take away 3x leaves us with 2x. We've still got that negative 3 there, and that now equals positive 9, so I won't bother putting the positive symbol. However, if there was a negative there, I would keep that in, just to emphasise that it is a negative 9, that's really important. So now we've got an equation just like the question before, so again we can add 3 to both sides, and we get 2x equals 12, and then we can divide that by 2. Again, I like writing that as a fraction, and 12 divided by 2 is 6, so we can write that as a whole number, x equals 6. Making x the subject of a formula, or any letter the subject of a formula. So this one's y equals 3x plus 5. So essentially, to make x a subject, we want it to say x equals. And we're going to rearrange these pieces and move them around, just like we did on that solving the equation. So the first thing I can do is I can get rid of that 5, just like before, and we can subtract 5 from both sides. Now I can't actually subtract 5 from y, so I'm just going to write that as y minus 5. And that now equals 3x. And just like before, we're just going to divide by 3. So if I divide by 3 both sides, thinking about how I did it before, I wrote it as a fraction like this. And that's what it's going to look like on the other side. It's going to be y minus 5 over 3 now equals x. 3x divided by 3 is just x. We've got x on its own. It doesn't matter that it's on the right hand side. We can rewrite it if we want. We can easily just rewrite x equals y minus 5 over 3. And there's our final answer. Got two slightly different ones here that look almost the same because we've got some fractions going on, but let's see how we treat these ones. So on this left, make x the subject. So again, what I could do is I could get rid of this 3 on the bottom to start with if I wanted, or I could get rid of this 5. I'm going to decide to get rid of the 5, so let's take away 5 from both sides. So if we take away 5 from both sides, we get y minus 5 equals x over 3, or x divided by 3. So to reverse a divide by 3, we're going to have to times by 3. So if I multiply both sides by 3, we'll get 3 lots of, and I'll put it in a bracket now, 3 lots of y minus 5 equals x. We could leave it like that, or we could expand this. We could say 3 lots of y is 3y, 3 lots of 5 is 15, copy the symbol, and then put in our x. Again, we could have done that a slightly different way. We could have times by 3 to start with. You'd have just had to remember at the starting point we'd be timesing this by 3, and we'd be timesing this by 3, just like we did in the end there. But that's our final answer. Now looking at this one on the right, it's slightly different because we don't have the option of getting rid of this 5 on the starting process here, because it's locked in by this divide by 3 on the bottom. So the first thing I'm going to have to do is times by 3 to remove this fraction to unlock what's on top there. And if we times by 3, we get 3y equals, and what's on the top is x plus 5. Now we can finish it off quite nice and easily. We can just take away that 5, and again that's going to make x the subject. So we have 3y minus 5 equals x, and again both of these questions we could rewrite it as x equals at the start if we wanted.
So a equals 5b plus 2c, b equals 3 and y equals negative 2, find the value of a. So we're just having to substitute these numbers in. So we're going to find out what a is. So a is going to equal 5 lots of b, and when I sub a number in I always put it into a bracket, so we have 5 lots of b, which is 5 lots of 3, and then 2 lots of c, so plus 2 lots of negative 2. We put these in a bracket like that, all we have to do is now multiply these, so 5 times 3 is 15, 2 lots of negative 2 is negative 4, and we're adding these together. So 15 add negative 4 is 11, remembering that these just become a takeaway, so it's 15 take away 4, so a would equal 11. There you go, just something to remember there. Whenever you're subbing numbers in, always put them into a bracket there, just so that you can sub them in and then deal with the calculations later. Okay, so on to solving simultaneous equations. Now we've got two equations here. I'm going to call this one 1 and this one equation 2, just so that I can talk about them. So when we're solving simultaneous equations, we want to make the coefficient, the number in front of one of the letters, the same. Now I always focus on this second one here, which in this case is the y. So on the top one we have 1y, and on the bottom one we have 3y. I know one of them is negative, but we'll deal with that later. I'm just purely looking at the number in front of it. So we have a 1y and we have a 3y. Now in order to make those numbers the same, I'm going to have to times the top one by 3, and that would make it a 3y. I don't have to times the bottom one by anything, but I might have to change them both in some of these questions. So let's have a look. If we multiply this top equation by 3, what does it become? So 4x would become 12x, the 1y becomes the 3y, and the number at the end will become 75. And that's my top equation. I'm going to rewrite the other one below it, which was 1x minus 3y equals 16. Now at this point I have the option, I can either add these two together or I can subtract them away from each other, but I want this 3y in the middle to get eliminated. Now if we think about the logics here, if I was to do 3y take away negative 3y, that would become a plus and I'd end up with 6y. So taking them away is not going to work, I'm going to have to add them together. 3y add negative 3y becomes 0. So if we add these two equations together, we get 13x equals 91. Okay, so there is a little way of remembering those. If those symbols there are different, you add them together, and if the signs are the same, you're going to subtract them. Okay, but here we are, we have 13x equals 91. If we divide both sides by 13, we get x equals 7. Now when it comes to simultaneous equations, we have to not just find the value of x, but we also have to find the value of y. So what I'm going to do is I'm going to sub x equals 7 into any of these equations that we've got written down. I'm just going to have a look at the start. I think this one's going to be the easier one for me, just because it's got a plus symbol. So if I sub x equals 7 into equation 1, I won't have that x there anymore, and we can start to work out what it is. So again, using brackets, I'm going to do 4 lots of 7, add that 1y, and that equals 25. Now 4 lots of 7 is 28, so we have 28 plus y equals 25. And again, we just need to now finish this off to solve it to find out what y is. Well, 28 add y is 25, it goes down, so it's got to be negative. If we solve this like normal, take it away 28 from both sides, we get y equals negative 3. And there's our final answer, y equals negative 3. So x equals 7 and y equals negative 3. I could have subbed this x equals 7 into any of the equations. I could have subbed it into equation 2. I could have even subbed it into this equation that we made up here if I wanted, but I think I just went for the easiest one there. So let's have a think. If I did sub it into equation 2, we'd have had 7 take away 3y equals 16. Doesn't quite seem as nice here, because now when we take away 7 we have negative 3y equals 9 when you take away 7, and then when you divide by negative 3, 9 divided by negative 3 is negative 3. So we could have solved it in that equation as well, but I've opted to go for the easier one there. Okay, so we've got some worded equations here. 3 calculators and 4 books cost £23, and 2 calculators and 3 books cost £16. Work out the price of a single calculator and a single book. So we have to create the equations ourselves here. So let's have a look. We've got 3 calculators and 4 books cost £23. Well, let's just call the calculator C, so 3C, and, so plus 4 books, let's call that B, equals 23, and we've got an equation there that looks similar to the last question. The next statement, we've got 2 calculators, so 2C, add 3 books, so 3B, equals 16. There we go, so we've got again an equation 1 and an equation 2.
Now we've got to follow that same process as before. I'm going to make these numbers, these coefficients of b the same, but this time I'm going to have to change them both, because one's a 4, one's a 3. So let's think, we could make those into 12, so I could times the top one by 3, and I could times the bottom one by 4, and that'd give me a 12 in the middle. So if we actually work that out, let's have a look, what do we get? Timesing the top one by 3, and let's move this around. Okay, so timesing the top one by 3, we get 9c plus 12b, and 23 times 3 is 69. Onto the one below, timesing them by 4, we have 8c plus 12b, and 16 times 4 is 64. Okay, so looking at these symbols, the signs are the same, they're both a plus, so the way to eliminate this 12b is to subtract these away from each other. So I'm going to do the bigger one on top, take away the smaller one on the bottom. So 9c, take away 8c, leaves us as 1c. And 69, take away 64 is 5. So straight away we get our answer there, c equals 5. So there's our first answer, c equals 5. And then we just need to sub that back into one of these equations. Again, I'm going to pick equation 1, I think. Let's have a look. We could do either one here, but I'm going to pick equation 1. So if c is 5, we have 3 lots of c, or 3 lots of 5. Add 4b, and that equals 23. There we go. Now 3 lots of 5 is 15, so we're going to have to take away 15 from both sides. And we get 4b equals 23, take away 15 is 8. And then dividing that by 4, we get b equals 2. There you go, 8 divided by 4, b equals 2. So our final answer there, we got c equals 5 and b equals 2. Obviously thinking about the context here, that was a calculator is £5 and a book is £2. So Adam, Brian and Chris are all work colleagues. Adam is 8 years older than Chris, Brian is twice as old as Adam. The sum of their ages is 92. How old are they all? Okay, so we can do this using equations as well. Now it says Adam is 8 years older than Chris and Brian is twice as old as Adam. Now it doesn't say anything about how much older Chris is than anyone else. So if let's call Chris X. Then what would Adam be? Now it says Adam is 8 years older than Chris, so Adam would be 8 older than that, exactly 8, so that would be whatever Chris's age is, X plus an extra 8. Then it says Brian is twice as old as Adam. Well, this is Adam here, X plus 8, so Brian is twice as old as that. So twice as old as that would be 2 lots of that, so 2 lots of X plus 8. And we could even expand that out now, so 2 lots of X plus 8 is 2X plus 16. So we have their 3 ages now in terms of algebra. We have Chris being X, Adam being X plus 8, and Brian being 2X plus 16. It says the sum of their ages is 92, so sum being to add them together. So if we add them all up and see what we get, we can have X plus the X plus 8 for Adam, plus the 2X plus 16 for Brian. And it says that they all equal 92. So if we start to simplify this, let's have a look. We've got x, x and 2x, which is 4x. And we have the 8 and the 16, which is 24. So 4x plus 24 equals 92. And now we can just solve this just like before. So I can take away 24 from both sides. Take away 4 is 88, take away 20 is 68. So we get 4x equals 68, and then we just need to divide by 4. So dividing that by 4, let's think, gives us 17. So x equals 17. So it does say how old are they all, so we could finish this off and we could just say, well, Chris was x, so Chris is 17. Adam was x plus 8, so Adam would be 17 plus 8, which is 25. And then Brian is twice as old as Adam, so Brian would be 50. Twice as old as 25, double 25. A nice little quick check there, you could just add those all up. 50 plus 25 is 75, plus the 17 is 92. So I'm happy that that works, it meets all those criteria. So the perimeter of the quadrilateral is double the perimeter of the triangle. Work out the perimeters. Now the lengths of each shape are given to us as expressions, so we could get an expression for each of the perimeters to start with. So let's have a look at that quadrilateral. Let's write that down over here. So the quadrilateral, we've got lots of pieces here, so let's count up these x's to start with. We've got 2x, plus this one's 4x, 7x, plus another one is 8x, so we have 8 x's. And the numbers, we've got a -3 and a -1, and in total that is -4. So that's the quadrilateral 8x minus 4, and that's an expression for the perimeter. Then we've got the triangle. Let's have a look what we've got there. We've got 1x, 2x, so 2x. And we've got 3, 4, 5, plus the 4 is 9, so 2x plus 9. Now it says the perimeter of the quadrilateral is double the perimeter of the triangle. So if we double the perimeter of the triangle, then that would be equal to the perimeter of the quadrilateral. Okay, so if we double this one, then those perimeters, those expressions for the perimeters would be equal. And if we double that, we get 4x plus 18. Now, because those two perimeters are now equal, we can set them equal to each other using an equation. So we can say this one here, the perimeter of the quadrilateral now, 8x minus 4, is equal to this one here, double the perimeter of the triangle. So that's equal to 4x plus 18. We can now just solve that like an equation, so we can get rid of the smaller x from both sides, so minus the 4x. So over here we have 4x, so we have 4x minus 4 equals 18. We can now add 4 to both sides, so get rid of this plus 4, so plus 4. And we get, let's do this over here, we get 4x equals 22. And then we've got to finish that off to find out the value of 1x, so dividing by 4, x will be 22 over 4, which is okay if we have a calculator, but 4 goes into 22 5 times with a remainder of 2, so it'll be 5 and 2 quarters, and 5 and 2 quarters is 5 and a half. So our final answer there, let's bring that up to here, would be 5 and a half, or 5.5. And again, it would have probably said in the question it was all in centimetres, or it was all in metres, so we just have a look at what units we'd apply there, but 5.5 is our value of x. Now it says to work out the perimeter of the triangle, so we can sub these back in if we want. So 5.5 would be here in place of this one, would give us 8.5, so that would be 8.5. 5.5 on the x plus 2 here would give us 5.5 plus 2, which is 7.5, and then this one over here is 4. So if we add those all up, 8.5 plus 7.5 is 16, plus the 4 gives us a perimeter of 20 for the triangle. We could have done the same with the quadrilateral, but it said the quadrilateral is double the triangle, so this one here must be 40. And again, we could have just subbed that into the quadrilateral there and halved it for the triangle, but we've got our two perimeters. Again, just not forgetting what units it was, not that I've put any units in this one. Okay, so work out the size of angle ABC in this pentagon. So A to B to C is this angle here, and that's got a 2x in there at the moment. Now it's a pentagon, it doesn't say it's a regular pentagon, it's definitely not because all the angles are different. But we need to know what the angles are in a pentagon this time. So a triangle, remember, is 180. A quadrilateral, we add another 180, is 360. And then a 5-sided shape, we add another 180, which is 540. So 540 degrees is what these all add up to. Now if we add them all up, again, like we did before, we've got 2x, plus another one is 3x, plus another one is 4x. So we have 4x's, plus all these numbers. So we have 121, 112 and 15. And if we add those all up, 121, 112 and 15, we get 842, or 248. So plus 248 has to equal 540 degrees this time. And there's our equation made, because we know all these angles have to add up to 540. So we've got slightly bigger numbers here, but let's take away 248. Take away 248, and it will tell us what those 4x's have to equal. So 540 take away 248 gives us 292. So 4x equals 292. And if we divide that by 4, it will tell us what the value of 1x is, and 1x comes out as 73 degrees. I'm not quite finished the question here because it does say for work out the size of angle ABC. Now the size angle ABC here is 2x, so 2 lots of 73, 2 lots of x is 146 degrees. So that one there would be 146. Again, we could work out any of these, we would know that that one now is 73. And x plus 15 down the bottom here would be 73 plus 15, which would be 88. And if you add those all up, just to double check, you will get 540 degrees, but our final answer there is 146 degrees. Okay, so a nice quick one here, solving an inequality. Now this symbol shouldn't put you off here. It's an inequality, yes, but we're going to treat it exactly the same as if it was an equal sign. So before we saw a question like this where it was 2x plus 3 equals 20. We're going to do it in exactly the same way, but we're just going to leave that symbol in there. So we're going to take away 3 from both sides, which leaves us with 2x is less than 17, and then dividing by 2, we get x is less than 17 over 2, and we could probably work that out. 17 over 2, half of 17 is 8.5, so x is less than 8.5. So find an expression in terms of n for this sequence. So we're going to do the nth term, and then it says hence find the 50th term. So what I always like to do is draw these little loops just to see what times table this is related to, and from 3 to 7 it goes up by 4, and then it keeps going up by 4. So this is related to the 4 times table. Now the expression for the 4 times table is 4n, if we do it in terms of n. Now this is obviously not the 4 times table though, is it? Because the 4 times table, if I write it above, is 4, 8, 12, 16, 20. And all of these numbers are 1 less. Look, from 4 to 3 is -1, from 8 to 7 is -1, so it's the 4 times table, but it's had 1 taken away, and that is our nth term there in terms of n. There is also a little trick that you can apply on this. You can go backwards 4, so if we go back 4, we get the number -1, and that always tells us how much smaller or how much bigger it is than the times table we're looking at. So it says hence find the 50th term. Well, here's our little code, 4n minus 1. To find the 50th term in the 4 times table, you do 4 times 50, and it's no different for this one, but it's the 4 times table take away 1. So we're going to sub it in, and we get 4 times 50, or 4 lots of 50, but then we have to take away 1. 4 lots of 50 is 200, and 200 take away 1 gives us 199, and that is our 50th term. Just thinking, if you didn't have this nth term, you'd have to just keep counting up from 19, so you'd go 23, 27 and so on, and you'd have to keep counting up to the 50th term, and it'd take you quite a long time, so this is a nice little shortcut for that. Here's another one. Find an expression in terms of n for this sequence, and then will 84 be in this sequence? Explain your answer. Let's have a look. It's going up in 5s, so our expression for the 5 times table is 5n, but this is not the 5 times table, because the 5 times tables goes 5, 10, 15, etc. So 6 is 1 bigger, 11 is 1 bigger, so it's the 5 times table, but it's got 1 added on, so that's my nth term this time again. We could have gone back 5, which would have given us the number 1, which is a positive 1, and that's just another way that we could have a look at it. Now it says, will 84 be in this sequence? Explain your answer. Now, there's 2 different ways of doing this. This one in particular, I'd like to use more of a logical approach. So if you have a look at all these numbers, 6, 11, 16, 21, 26, they all end in 6 or 1. So I would be able to say no, because all the numbers end in 6 or 1. Okay, because they all end in 6 or 1. But there is another way of doing this. There we go, they all end in 6 or 1. Okay, so that's option 1. There is another way, because it might not be that there's a pattern, so my second option is I can actually just make an equation. I can just say, well, does 5n plus 1, does it ever equal 84? And that's what that means there. Does 5n plus 1 ever equal 84? And we can solve that. So taking away 1, we get 5n equals 83. And then if we divide by 5, we get 83 divided by 5, which is not a whole number. So I could say no, n's not going to be a whole number, the position is not going to be a whole number. Okay, so not a whole number. Now I'd obviously just have to make that statement, no, not a whole number. Okay, so draw the graph of y equals 2x minus 1 between the values of x equals minus 2 and x equals 3. Now there's 2 ways of doing this. Again, we could make a nice little table, and we've got x values and we've got y values. Remembering this equation just means to find the y coordinate, you do 2 times the x coordinate or double the x coordinate and take away 1. Now it says between minus 2 and 3. So if I'm going to do a little table, I'd do minus 2, minus 1, 0, 1, 2 and 3. And all I've got to do is double them and take away 1 as the equation says. So if I start at the end with this positive number, double that is 6, take away 1 is 5, double 2 is 4, take away 1 is 3, double 1 is 2, take away 1 is 1. Now you might start to see there's a bit of a pattern here. Look, 5, 3, 1, those are all going down in 2s. So I can just follow the pattern here. 1 take away 2 is minus 1, and take away 2 again is minus 3, take away 2 again is minus 5. And we've got our coordinates here. Just looking at this one, that coordinate is minus 2, minus 5 as a coordinate. And all we've got to do is plot these and join them up with a ruler. So that's one way that we can do it. And I'm going to just draw that in to start with. So minus 2, minus 5's here, minus 1, minus 3, 0, minus 1, and the next few go there. And then nice and neatly with a ruler and a pencil, joining that up with a straight line. Absolutely not like I've just done there, which is absolutely terrible, but as best as you can with a straight line and a ruler. Okay, so that's one way that you can do it with a little table. You can actually do a little trick with this one, which is quite nice if you know what these pieces in there mean. So the 2 in front of the x, let's draw this over here, y equals 2x minus 1. The 2 there represents the gradient, and the minus 1 there represents the y-intercept. Okay, where it crosses the y-axis. So let's have a look there. It does cross through minus 1, so we could have put that point on straight away because we know it goes through minus 1, and then we could have had a look at the gradient, and that gradient of 2 just means for every 1 across, let's think from that point, so 1 across, it goes 2 up, and it goes 2 up. So you could do a little staircase here. You could just go again, 1 across, 2 up, 1 across, 2 up, to keep finding those coordinate points, and then tracing it backwards, so 2 down, 1 left, 2 down, 1 left, and you can draw this little staircase in. That's another way of doing it as well. Slightly different one, so draw the graph of y equals x squared plus 2x minus 3 between minus 3 and 2. Now again, I'm going to do a little table for this. So we have x and y, and it's between minus 3 and 2. So minus 3, minus 2, minus 1, 0, 1, 2. Now this is a slightly more complicated one for us to sub in, because to find the y coordinate you have to do x squared, add 2x, take away 3. So I want to write these down nice and carefully. So I'm going to start with 2 again for the positive one. So we have 2 squared plus 2 lots of 2, take away 3. I'm just going to work that out nice and slowly. 2 squared is 4 plus 2 lots of 2, which is 4, take away 3. So 4 plus 4 is 8, take away 3 is 5. So my answer there underneath the 2 is going to be 5. Now I need to follow this process for all of them, but the one thing I do need to be careful of is when we get to these negative numbers. So up here, where I put 2 squared in, just here, we should really make sure we keep that in a bracket, because as we get down to those negatives, it's going to have a big effect on that, and we'll see what happens when we get to them. Now I'm going to do the other ones a little bit quicker. Let's have a look. So 1 squared is 1, add 2 is 3, take away 3 is 0. 0 squared is 0, add 0 is still 0, take away 3 is negative 3. And here's where we need to be careful. So the first one here is negative 1. So I need to put, if I'm going to do this on a calculator, I'll write my working out down. Negative 1 squared, add 2 lots of negative 1, and then take away 3. Now the reason you have to put this in a calculator is because if you put negative 1 squared without the brackets, it will give you the answer negative 1. It will square the 1 and put the negative with it, rather than doing negative 1 times negative 1. Squaring a negative number makes it positive, so negative 1 squared is 1, add 2 times negative 1 is negative 2, and take away 3. So 1 take away 2 is negative 1, take away 3 is negative 4, so we get negative 4 for that one. There we go. Let's have a look at the next one. Negative 2 squared is 4. Add negative 4 is going to be 0. And then take away 3 gives us negative 3 again. And then onto the negative 3. Negative 3 squared is 9. Add 2 lots of that, so negative 6. So 9 take away 6 is 3. And then take away 3 again gives us 0. So you can probably see a little bit of a pattern here. Look, if you look at that negative 4 in the middle, either side of that we've got negative 3. Either side of that we have 0. And then we have the additional 5 there. But let's just plot these and see what it looks like. So negative 3 to 0 is there. Negative 2 to negative 3 is there. Negative 1 to negative 4 is here. 0 to negative 3. 1 to 0, and 2 to 5, which is all the way up there. There we go. So this forms a quadratic curve, a parabola, and we just need to draw that with a nice smooth curve as best you can, going through all the points, making a nice smooth curve. And there's our graph drawn. Just as a note, we could also have a cubic graph. So we could have an x cubed up here, and we just treat that in exactly the same way, subbing the numbers in very carefully using brackets. And it tends to be that a cubic graph has this sort of shape. So just be careful. There are some others as well. We could have a reciprocal graph, where we have something like y equals 3 over x. And that has a different look again. It has this sort of curved shape within the positive part of the graph. So there's lots of different graphs that we can have a look at, but just treat it all in the same way and plot the points very carefully, joining them up with nice smooth curves. Okay, so back to a straight line graph. Find the equation of this line and give it in the form y equals mx plus c. So I'm going to use that little trick process that I saw before. We're going to have a look for two coordinates here. I've got one coordinate there and another coordinate here. Now if we go across 1 on the x-axis, being careful of the scale here, because although mine goes up in ones, sometimes you might have 2 squares for every one, so just be careful of that. Now it goes across 1 and then it goes up 2. So it goes across 1 and up 2. So every one across it goes 2 up. So the gradient, the value of m, is 2. All we've got to find is that value of c, which as we've already said is the y-intercept, and it crosses the y-axis down here at -3. So c is going to be -3. So I just need to put those all together. We have y equals 2x take away 3. That's the equation of this line. We can do that nice and quickly like that. It goes through -3 on the y-intercept, and there's a gradient of 2 which I've found between those two whole number coordinates there. Slightly different one here because it's sloping in the other direction, but the same type of question. I'll take the same approach, so I'm going to find the y-intercept to start with this time, so c equals 1, and then we just need to find the gradient. So let's pick two coordinates. We've got one here and one here, and now this time for 1 across it goes 2 down. So 1 across it goes down 2. So my gradient this time is going down, and we'd say it's -2, so the gradient is -2. So y equals mx plus c, we have y equals -2x plus the positive one there for the y-intercept, and there's the equation of that line. Okay, so share £240 in the ratio 5:7. So if we're splitting this in a ratio, let's have a look. We've got in total here 5 plus 7 equals 12 parts. Okay, so if we split this into 12 parts, we could do 240 and divided by 12. And 240 divided by 12 is 20. So in each part there's £20. Now there was 5 parts and 7 parts, so those 5 parts are going to be 5 lots of 20, which would be £100, and the other part there was 7 parts, and that times 20 would give us £140. So splitting it in the ratio 5:7 gives us 100 to 140. And the last little check you can do here is just to add these two together, just to make sure you do get that £240 that you started with. So we're happy with that as a final answer. So Craig and Ian share some money in the ratio 8:3. Craig receives £32. How much does Ian receive? Well, C to I, Craig to Ian, was in the ratio 8:3. And it said that Craig receives £32. So that is this first number 8 here, that is 32. So all we've got to think about is how do we get from 8 to 32? So 32 divided by 8, which we can do to the side, 32 divided by 8 is 4. So we must have times by 4 to get there. So if we do the same to the other side, times by 4, 3 times 4 is 12. So there we go. How much does Ian receive? Ian receives this 12. So I'll just say £12. Final answer. So Emily and James share some money in the ratio 4:7. James receives £21 more than Emily. How much do they share between them? So Emily to James is in the ratio 4:7. Now it says that James receives £21 more, and if we look at these two numbers here, from 4 to 7 is an extra 3 parts. There you go, it's an extra 3. So that extra £21 is 3 parts. So if 3 parts of this ratio equals £21, then 1 part must be, to divide that by 3, must be £7. And from there we can work out how much they both receive. If it was 4 to 7, let's get rid of this little bit down here. And each part is now worth £7. Well, 4 times 7 gives us £28 for Emily, and 7 times 7 gives us £49 for James. So Emily receives 28 and James receives 49. It says how much do they share between them? So if we can add these together, it gives us the total amount. So 49 plus 28 gives us 7 and 7, so £77. There we go, so they share £77 between them. A to B is in the ratio 3:5 and B to C is in the ratio 2:1. Work out the ratio A to B to C. So if we write out A to B to C and start to write what we've got so far. Now it says A to B is in the ratio 3:5 and then it gives us B to C. So there's an overlap in these, there's a B in both. So I can't put another number just over the top of the 5, so I'm going to start a new level. I'm going to write the other one underneath. So B to C is 2:1.
Now looking at this, if I can make these middle numbers the same, I can merge these ratios together, I can squish them together essentially. So let's think, 2 and 5 can make 10. So if we times the top one by 2, that would make that 5 a 10, and we'd have to times the bottom one by 5. So if we times the top one by 2, that 3 becomes a 6, and the 5 becomes a 10. Looking at the one below, timesing that by 5, 2 times 5 makes 10, which we've already got in the middle, and 1 times 5 is 5. And there's my ratio A to B to C, 6 to 10 to 5. Just have a look to see if you can simplify in any of these questions, but it doesn't actually ask us to simplify it there. The ingredients to make 16 biscuits are 150 flour, 100 butter, 75 sugar and 12 grams of almonds. Alice has 140 grams of butter and is going to make enough biscuits for 24 people. Does she have enough? Well, whenever we're doing this, look, this is a recipe for 16 and we can start to break this down, particularly a non-calculator way here. If we want to get half of that, that's going to be 8. So half of all of those would be 75 grams of flour, be 50 grams of butter. It'd be not a very nice number here. 75 divided by 2 is 37.5 grams of sugar, and half of 12 is 6 grams of almonds. Now we could keep going. We could halve this again for a recipe for 4. We could halve it again for a recipe for 2. We could halve it again for a recipe for 1. Or we could have just divided all of these by 16 if we had a calculator to straight away get a recipe for 1. I'm going to assume this is a non-calculator though, but it says we want a recipe for 24 people. And if we have a look, 16 people, oh, didn't mean to erase that, there we go. So 16 people in this recipe and 8 people in this recipe. Well, in total, 16 plus 8 is 24 people. So if we combine these together, the recipe for 16, the recipe for 8, that'll give us a recipe for 24. So for 24 people, we can add these together. So 150 plus 75 is 225 grams of flour. 100 plus 50 is 150 grams of butter. 75 plus 37.5, not very nice one there, gives us 112.5. And 12 plus 6 gives us 18 grams for that last one. Now it says, we're actually only looking at the butter here, but I've gone ahead and done the whole recipe. But it says Alice has 140 grams of butter, and if we have a look, the actual amount of butter that we have, or we're going to need, is 150 grams. So if she only has 140 grams, we can say no. Okay, she needs 150. But there's a little process there for working out any sort of recipe there that we can make combinations of those smaller amounts of recipes. 3 tins of beans and 4 jars of jam weigh 2,080 grams, and the total weight of 5 tins of beans is 1,800. Work out the weight of 1 tin of beans and 1 jar of jam. Well, straight away we can work out the weight of 1 tin of beans from this, because it says 5 tins of beans is 1,800. So if we do 1,800 and divide it by 5, we get the answer 360. There we go. We might have to do a bit of bus stop for that, but we can do that. 5's into 1,800. 5 into 18 goes 3, remainder 3. 5's into 30 goes 6, and then 0. So 360 grams, and that is for the tin of beans. So tin of beans. There we go. It then says 3 tins of beans and 4 jars of jam weigh 2,080 back in the first line. So if we work out the weight of 3 tins of beans now, well, 3 of those would be 360, 360 and 360. And if we add those all up, we get 9, 10, 1,080. So that's the weight of those tins of beans. So if we subtract that away from this original amount, so 2,080 take away 1,080, that leaves us with 1,000 grams. So those 4 jars of jam, so 4 jars equals 1,000 grams, and we want to know the cost of 1, so we can divide that by 4, and it gives us 1 jar equaling 250 grams. So there we go, 1 jar is 250 and 1 tin of beans was 360. We've got some proportion here. 6 taps take 3 hours to fill a tank with water. How long will it take 9 taps to fill the same tank? And then we're going to state any assumptions that we've made. So if 6 taps take 3 hours, it will take 6 times as long as that for 1 tap. So 1 tap would take 3 times 6, which would be 18 hours. It takes 6 times longer. So 1 tap takes 18 hours. So from here, if we know how many taps we've got, we can just divide this 18 hours by however many taps. If we have 2 taps, we can divide it by 2, which would give us 9 hours. We could do 3 taps, divide it by 3 would give us 6 hours, but this particular question here said that there's 9 taps. How long would it take 9 taps? So if we do 18 hours divided by the 9 taps, it gives us a total answer of 2 hours. So these questions are all about working out first, how long would it take one tap, or whatever this question's actually about normally. So it says state any assumptions that you've made. Well, I've assumed here that all these taps are running at the same rate. Okay, that's my assumption. All taps run at the same rate. There we go. So obviously in that original statement there, 6 taps take 3 hours, while one of those taps might be running a lot faster than the other, and that would change our answer. So we are assuming that all the taps are running at the same rate. Okay, so working out the size of angle x. Again, I've got 2 here, and we're looking at parallel lines. As you can see by these arrows here, these lines are parallel. So there are 3 rules that we're going to really look at when we're looking at parallel lines, as well as all our normal angle rules. We've got alternate angles, corresponding angles, and co-interior angles. So if we look at this one on the left here, 110, there's lots of angles we can find now. So all around this point here, we can find all of these angles. Vertically opposite the 110 is also 110, and then next to the 110 on the straight line there, bring angles in a straight line up to 180, these would all be 70. There we go. So it's up to you really how you actually find this final one. I'm going to have a look at finding this Z shape here, which is an alternate angle, and alternate angles are equal. So this 70 here is the same as this 70 here. So x would equal 70 degrees in this one. And we've normally been asked to give our reasons there. So my reason may have been angles on a straight line equal 180, and that's how I got the 70. And then I would have said alternate angles are equal, and that's really important the way you say that. So alternate angles are equal. Okay, there are also other ways that I could have done that. If I flick to another colour, we could have said, okay, well if this is 110, well then this here is also 110, because those angles are corresponding. And again, I'll try and draw this on a different colour, but they make this F shape, okay? So that 110 and that other 110 are corresponding angles. So we could have done it that way and then done angles on a straight line. Let's have a look at this other one. So 105 degrees down in the bottom here. So straight away, just above that, we can find that this angle's 75, because angles on a straight line equal 180. Now, if you have a look, we've got a triangle in this question. Now, there's these 2 symbols here, which tell us that this is an isosceles triangle, and base angles in an isosceles are equal, and it's underneath these 2 little, what I call little eyebrows. Okay, so underneath, this will also be 75, because base angles in an isosceles are equal. We can then find this missing angle here, because angles in a triangle equal 180, so those 2 75s equal 150, and if we take that away from 180, it leaves us with the other angle in that triangle being 30. There we go. And there's all the angles that we found just using basic angle facts. Now to get that angle x, there's a couple of ways we could do it. We could find this angle here, and then do angles on a straight line. Or we could again identify that actually we've got one of these alternate angles going up, making this Z shape again. So that's an alternate angle with the 30. So that's 30 degrees as well. So for this one, we'd say x equals 30. And again, we'd probably give this same reason over here that alternate angles are equal. Unless, of course, we took a different approach, which we could have done. Again, lots of different ways that you can tackle these questions, but a few there that you need to make sure that you try and remember. So working out the size of the angle between this regular octagon and regular hexagon. So there's different ways that you can approach this, but we need to know what the angles inside a hexagon all add up to and what the angles inside an octagon add up to. There's different ways of doing this. You can do the 180 list rule, so you can keep adding 180, so 3 sides is 180, 4 sides is 360, 5 sides is 540, and you can keep doing it this way, or you can apply a bit of a formula. So I'm going to go for the formula, even though I've started writing this down, but that is an option there that you can use. So for 6 sides in a hexagon, we take away 2, so 6 take away 2, which is 4, and then 4 times 180 tells us the total amount of, oh, that should be a times sign, let's change that. 4 times 180 gives us the total amount of angles in a hexagon, which is 720. So all the angles inside a hexagon equal 720, and there are 6 equal angles in there. So if we divide that by 6, 720 divided by 6 gives us 120 degrees. So all of these angles in the hexagon are 120. Obviously we're concerned about this little area here in this question, because we're trying to find the angle between them, but we've got the angle in the hexagon, and that's really important. When you see these words regular hexagon and regular octagon, always just work out the interior angle and label it all over the diagram. So moving on to the octagon, same process, 8 sides, take away 2 is 6, and then times that by 180. There you go, and 6 times 180, which is okay if you have a calculator. If not, you just have to work that out, but 6 times 180 is 1080. And again, it's got 8 equal angles, so if we divide that by 8, 1080 divided it by 8 gives us 135 degrees. And again, we can just label that all over the diagram. So 135, 135, and lots of these, but I'm concerned again with this little area here. So angles around a point equal 360, and at the moment we've got two of these angles, kind of like a jigsaw. So if we add these two together, 120 plus 135, at the moment we've got 255 degrees, and we need it to add up to 360. So to finish that off, if we do 360 and take away that 255 that we've just worked out there, we get a missing angle of 105 degrees, and that's our final answer there, 105 degrees, which we could always label on the diagram as well, 105. And there we go. So whenever you see these questions where it says regular octagon, regular hexagon, okay, just spot these bits of language here, just work out their interior angles and label it all over the diagram. Right, working out the area of a trapezium. There's a formula for the area of a trapezium. It's a plus b over 2 times by the height. Or it can be written in a slightly different way. You can say half a plus b, again timesing by the height. Now a and b are the parallel sides, which in this case is the 5 and the 9. So we add those together to start with, so 5 plus 9. We halve that, so 5 plus 9 is 14, half of it is 7. And then we times that by the height. Now you've just got to be careful here because you are given these two lengths on the side and they're really there just to throw you. They're not the height, they're diagonal lengths. This 4 in the middle is what we want, the perpendicular height from the base, indicated by that red arrow there. So 4 is our height, so we're going to do 7 times 4, which gives us 28, and it is an area, it's in centimetres again, so centimetres squared. So just be careful with the trapezium there that you do identify the perpendicular height from the base. So we've got to work out the surface area of this cuboid. Now there's only 3 surfaces we can see. We've got this one on the front, but there's also one on the back that's exactly the same, back here that we can't see. We've got the one on the top, number 2, which is the same as the one on the bottom, and we've got this one on the side here, which is the same as this one that we can't see on the side. So if we work out the area of these 3 faces, we can just double our answer to get the ones on the back as well. So I'm going to do this in steps. I'm going to do the face number 1, which over here is 8 times 12. So 8 times 12 is 96 centimetres squared. Face number 2, the one on the top, we've got 14 along there, and it's not labelled, but this is 12 as well, the same as the bit below just down there. So that's 14 times 12. So 14 times 12, you've just got to work that out, and that's 168. That's 168 centimetres squared. And then the last one, face number 3 on the side, it's not labelled, but we can label that the height's 8 and the length going backwards is 14, the same as on the length on the top there. So we've got 8 times 14. So 8 times 14 for our last one. 8 times 14 is 112. So that's 112 centimetres squared. And if we add all of these up, 112 plus 168 plus 96, we get the answer 376 centimetres squared. Now you've just got to be careful at this point, obviously don't forget there are 2 of each face, so we just need to double our answer or times that by 2. So times that by 2 gives us a total surface area here of 752 centimetres squared, and there's our final answer for the surface area. Working out the volume of a cuboid is quite nice and simple. I do like to do it in a particular way though, just so it's the same for all of these shapes where we have a constant cross section. So this cross section, I'm going to have a look at this front face just here. So I'm first going to just work out the area of that, which is 8 times 12. So 8 times 12 gives me 96, and that is the area of the cross section, 96 centimetres squared. And then to get the volume, we just times it by however far back the shape it goes, which is the same as that 14 back there. So times that by 14, 96 times 14 will give us our volume. So 96 times 14 is 1,344, and it's a volume, so we put centimetres cubed, and that's how you work out the volume there. That works for any shape. We've got a constant cross section. If you imagine, sometimes we have these triangular prisms, and sometimes we could even have a trapezium face prism there. Okay, anything with that constant cross section, you always work out the area of this front face to start with, the cross section, and times it by the distance it goes back. Okay, so we've got that these 2 shapes are mathematically similar. Work out the length of A and B. Now that there, mathematically similar, means one is an enlargement of the other, which means there's a scale factor between them. So if we can identify a similar side on both of them, which we've got here, 4 and 10, we can find the scale factor. So we always just do the big one divided by the little one. So 10 divided by 4, And 10 divided by 4, 4 fits in twice and a half, 4, 8, and then an extra 2, so it's 2.5. You might just get a whole number there, but there's my scale factor. And I always label that, I just say SF, so the scale factor is 2.5. So to get from a small one, let's have a look at A to start with. We've got to get from 7.5 back down to A. So that's going from the big shape down to the little one. So to get from the big one down to the little one, we divide by the scale factor. So divide by 2.5, and 7.5 divided by 2.5 will be 3 centimetres. And that's actually going to show the same for this other one here, look, because this one's 3 as well. But to get from 3 to B, we actually just times by that scale factor, so times by 2.5, and 3 times 2.5, which we already have there, is 7.5 centimetres. Okay, so you just got to remember divide from the big to the small one, and then multiply by that scale factor to go from the small to the big one. But it's all about identifying that scale factor that we did up here, that 2.5. Here we go, working out some bearings. So write down the bearing of B from A. So if I'm at B and I want to go from A, then I'm standing over here at point A. Now there's 3 rules for bearings. They're always measured in a clockwise direction. There's always 3 digits. I always measure it from north. Okay, so they are my 3 bearing rules. So looking here, if I'm standing facing north, which is shown by the north line, I turn clockwise, I'd have to turn this full 60 degrees. So that thing there, 60 degrees, but it doesn't have 3 digits, so I stick a 0 in front of the 60. So it'd be 060 degrees, or 060 degrees. Now the next part of the question says write down the bearing of to A from B. So that means now I'm standing at B. So let's just get rid of these little bits. So this time A from B means I'm standing at B. Now obviously following these rules, if I face north, I've got to turn all the way around this way to get back to the direction of going back to A. So let's have a look at how we can do this. Now what I quite like to do with these sorts of questions is to think about if I can extend the line slightly. So if I extend the line, because these 2 north lines are parallel, we've actually got a corresponding angle there. So this bit here is actually 60 degrees. So we can think about other angle rules while we're doing this. So from that bit just down to my little dotted line, I've put in is 60 degrees. Now because this is a straight line, this extra bit here is an extra 180 degrees. So actually what I've got there is 60 to get me down to here, and then an extra 180. And if we add those together, 60 plus 180, we get a total of 240 degrees. So my answer for that would be 240 degrees, which does have 3 digits, so I can just leave it like that. Of course, there is another way that you can look at this as well. We could think about these 2 angles here as being co-interior that add up to 180. These 2 add up to 180. So this one here must have been 120. So actually I could take away 120 from 360, because that full turn there is 360, and we've got this little bit here as being 120, so I could actually do it like that as well. So there's 2 ways that we could approach it. Okay, so translating a shape by a vector. Now that top number in a vector means left and right, and the bottom number means up and down. Okay, thinking about positive numbers moving towards these positive numbers on the axes, and negative numbers moving towards the negative numbers as well. So 4 moves it right towards the negative numbers by 4. So all I ever do is pick a point, you can pick any, and I move it right by 4. So 1, 2, 3, 4, it's going to end up there. The next thing I do is look at the other number, which is minus 2. Now negative 2 moves down towards the negative numbers. So 1, 2 down. And that means that new point is going to end up just there. So all I have to do is draw this triangle in exactly as it is from that top point. So it goes down 3 and across 2. And there we go, we can just draw it in like that. Not forgetting as well, you might actually be asked to describe a translation, in which case you'd say it just like it says above. You'd say translate the shape by a vector, and you'd say what the vector is. Okay, so reflect the shape in the line x equals 1. Now this is your x-axis and this is your y-axis, so x equals 1 is right there. And the only line that you can do from that point, other than going across the x-axis, and it doesn't say the x-axis, is to go up and down. So x equals 1 is this line here. If you think about any coordinates on that line, the x-coordinate's always 1. So that's our reflection line there. Now we're going to reflect it in that line, which is quite nice and easy to do. Pick a point, and we just go 1, 2 to the line, so 1, 2 away, and just follow that process for all the points. So picking this point, that is 4 away, so another 4 away gets me to there, and the same one at the top, that's 4 away, and 4 away gets me to there, and then just joining it all in, obviously using a pencil for this one, and that would be my triangle. I haven't drawn that in particularly neatly, there we go. Okay, not forgetting as well though, you could have a line, it could say the line, I don't know, y equals 3, which would be across at y equals 3, which would be across here. There's another couple of lines that we could have as well. We could have this one, y equals x. The line y equals x is the diagonal line here where all the x and y coordinates are equal, so we could have that one as well where we have a diagonal. There's one more that we could have as well. Let's pick a different colour for this. We could have y equals negative x, which is very similar to the one above, but it's pointing in the opposite direction. And if I do that in blue as well, that's going down this way, so we could also have to reflect in a diagonal line, but again you just follow the same process, counting diagonally. Okay, so rotate the shape 90 degrees clockwise about the point -1, 0. So first thing to do is obviously to locate that point, which is -1 across, not up and down, so -1, 0 is just there. The next bit, this is a lot easier if we have some tracing paper. So you stick your tracing paper nice and flat over your shape, trace it in, so trace over your shape, stick your pen on that rotation point and just rotate the tracing paper, not moving it away from the pen. So we would rotate it 90 degrees, so it would be facing this way and just making sure it stays nice and flat, and it would rotate the shape. Let's have a look. It would go to here on your tracing paper, and then you would just lift your tracing paper up nice and carefully and draw it in at that spot. And again, the same process if you have to describe one of these, you stick your tracing paper over the top and just move your pen into different points, picking places like here and moving it around until you get the one that matches when you swizzle your paper around 90 degrees. And remembering obviously in your description you need to put the amount of degrees, the direction that it's gone in, and that rotation point along with the words rotation. Okay, so enlarge the shape by a scale factor of 2 from the point -4, -3. So let's identify that point first, -4, -3, and then we're just going to enlarge it by a scale factor of 2. So what I do is I pick a point on the shape, normally the closest one, let's say this one here, and I just think, right, how do I get there from the point? So we go 2 across and 1 up. And I'm just going to do exactly the same again. So 2 across and 1 up. And that there is a scale factor of 2. The first movement to the shape is my first scale factor, the second is my second scale factor there. So if I had a scale factor of 3, I'd do the same again. I'd go 2 across 1 up, and that'd be a scale factor of 3. But this one has just set a scale factor of 2, so I'm going to leave it there. Now if I have a look at the shape that's drawn originally, it's 2 along and it's 3 up. And this is going to enlarge it by a scale factor of 2, which doubles those numbers. So it's no longer going to be 3, it's going to be 6, and it's no longer going to be 2, it's going to be 4. So from this point here that we've got to, all I need to do is redraw that shape in, remembering it was the bottom left corner, this one here. So we'll just need to go 4 across, 1, 2, 3, 4, and 6 up, 1, 2, 3, 4, 5, 6. And then join it all up, nice and neat with a pencil and a ruler, and there it is, enlarged by a scale factor of 2. Just remember, if you have to describe one of these, it's a really nice way of doing it as well. You just pick the 2 corners, get your ruler and a pencil, join them up really nice and neat, pick another one, match it with the appropriate one, and then again join that up really nice and neatly, and it will show you down here, look, where that enlargement point came from. And you can find the scale factor by just looking at the sides. So the side length is 6 here, and the side length is 3 there, and 6 divided by 3 gives us a scale factor of 2. So if it was already drawn in, we found our enlargement point, we just say it's an enlargement, a scale factor 2, and from this point down here, just like it did in the question, enlargement, scale factor 2, and from this particular point. So reading from a stem and leaf, it says the speed of 27 cars, work out the median and work out the range. So to work out the median, I want to know which one's in the middle. We can take quite a nice approach for this. We can just cross numbers off either side until we get to that middle number. So if there's 27, I'm going to cross off 10 from each side at least, so I can start to get from the middle. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And then going from the back, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Now I'm just going to do 1 from each side until I get one in the middle. So 1 and 1, 2 and 2, 3 and 3, and I'm left with this one here. Don't forget the key though, it says 3-8 or 3 line 8 means 38. So that's next to the 5, so it's 5 and 6, which is 56. So the median there would be 56. Working out the range, we want to look at which one's the smallest and which one's the biggest. Let's have a look. If I get rid of some of my lines here, the smallest number there is 38, the biggest is 70. So to work out the range, which I'll do up here, so the range will just be 70 the biggest, take away 38 the smallest, which is 32. as my range there. Again, there's median and range from a stem and leaf. Okay, so drawing a pie chart. We've got to draw an accurate pie chart for this information. So the good thing about a pie chart is these numbers in the table are always going to fit into 360. Now, this is quite a small one here, because if I add these up, I've only got 10 people in this pie chart. It looks like the type of fruit that they prefer maybe. So we've got 10 people, so all I want to figure out is how many times this fits into 360. So whatever that number adds up to, I can do 360 divided by that number, and it tells me that each person here represents 36 degrees. So all I want to do is times the amount of people by 36 in each scenario, or times them all by 36, and that will tell us the amount of the degrees I need to draw in my pie chart. So 2 times 36 is 72, 5 times 36 is 180, and 3 times 36 is 108. And again, it's quite a nice check here. If you add those up, they have to add up to 360. And if we add them up, let's have a look. 108 and 72 makes 180, plus the 180 is 360 degrees. So that's a nice little check there. You can tick that off, happy with that as 360. Now moving on to the next part, we actually have to draw the pie chart. So whatever kind of protractor you've got, you need to stick it over the top using this first line here as your starting line and measure out 72. Now if I guess where it's going to be about there. And all you need to do then is draw inside that piece of the pie what that represents. So that represented apple, and it represented 72 degrees. Then drawing in your banana there, which is 180, which is going to be a straight line going the other way. Again, measuring from this line as your new starting point, and that is going to be banana. Ooh. Banana, and that is 180 degrees. And then your final one there, because I've only got 3, the final one's done for me, although stick your protractor on and just make sure that this distance here is in fact the 108 degrees that we want, just to make sure you've done it all correctly. And you'll get an orange in there with 108 degrees. Now just remember, when it comes to a pie chart, if you ask then to compare this against another group, let's imagine we have another pie chart. I'm going to draw a really rubbishy one over here. We have another pie chart, and let's say that this size is apple now. So we've got apple, banana, and orange, and it says something along the lines of more people like apple in this pie chart. Now without any numbers, we can't actually make any statements like that. So if you are given a pie chart to compare, just remember, without any numbers you can't actually make a comparison, because there might only be 5 people in this pie chart, for example, in which case it might not necessarily be more people. Onto a scatter graph. It shows the time spent revising and the amount of mistakes made by 10 students in an exam. So state the coordinates of the outlier. Well, there's one point there which doesn't fall into the general pattern of this scatter graph, and it's this one just here. So I'll just state the coordinates there, and it's 4 below, and it goes up to 10, so I would say the coordinates are 4, 10 for that outlier just there. Now it says to describe the correlation. Now when it comes to a scatter graph, whether you're asked to or not, it's always a very good idea to draw in a line of best fit. So get your ruler, get your pencil, draw a nice straight line going in the general direction of the points. Now this particular one is going upwards, or it's sloping upwards, and we say that that has a positive correlation. Positive correlation. Stick in that word correlation there regardless of whether it's said. So positive correlation. The only other one is it could be sloping downwards in this sort of direction, and we would say it had a negative correlation. If there was no trend with the points, which is very unlikely on one of these questions, but if it's not sloping up or down, you'd have to say it had no correlation. And the final part of this question, it says, another student revises for 9 hours, estimate how many mistakes they'll made. So that's what we use this line of best fit for. So 9 hours is down here in between 8 and 10. So very, very carefully going up from 9, hit your line of best fit, and bounce off to the other side, and then as accurately as you can read that. On my screen it looks around 62, so I would say 62 marks as would be an estimate for the amount of mistakes that they would make. Okay, so they would get 62 marks. So actually, if it's out of 100, they would make 38 mistakes there. So just be careful what the question says. So they get 62 marks, which would be 38 mistakes. Okay. There we go, so 62 marks will be 38 mistakes. Okay, and the nicest of all the graphs is a frequency polygon, so really nice and easy to draw. All we do is we pick the midpoints in here and plot it against these numbers. So the midpoints, I'm just going to write them to the side. 25 is between 20 and 30, 35, 45, 55 and 65, and just plot them against these numbers here for the frequency. So 25 up to 8, as accurately as you can, is there. 35 up to 13 is here, 45 up to 25, so 45 to 25 is there, 55 to 10 is here,
and the last one there, which is 65 to 4, is here. And then very carefully with a ruler and a pencil, from the first cross there to the last one, join them all up nice and carefully with a ruler and a pencil. Make sure it's not a curvy line, nice straight lines, and that's how you draw a frequency polygon. Okay, the table shows the probability of picking different colours. So we have red, blue, white and black, and it says the probability of white and black is the same, complete the table. So at the moment, we've got these two which add up to 0.7, and probabilities have to add up to 1. Now what we've got left over there is 0.3. I like to think of it as 0.30 because if they're both the same, we're going to have to halve that, and half of 30 is 15, so it's 0.15 for both of those, and now they add up to 1. Now for part B, it says that there are 60 counters in the bag. How many are white? Now if we look at the probability of white, which is over here, 0.15 is 15%. So really all this is asking us to do is to work out 15% of 60. And we can do that nice and easy. 10% is 6, 5% is half of that, which is 3, and add them both together, and that's 9. Now part C here, you won't be given this at the same time as question B because we already know that there are 60 counters in the bag, but it says that there are 12 red counters, and how many counters are now in the bag. So if we imagine this is a completely different question now, but it's saying that red counters here, which is 20%, is now 12 counters. So all that's actually saying is 20% equals 12 counters. Now that's okay, we can turn that back into 100% quite nice and easy. I could just times that by 5, but let's imagine it's not a nice percentage. I'd have to try and break it down to something which turns into 100. So we could divide it by 2, which would give us 10%, which is half of 12, which is 6, and then times that by 10 to get us back to 100%. Okay, again, you could actually just times 20% by 5, but I think that's quite nice just to break it down and build it back up. So 60 counters there would be in the bag. Okay, so we've got a lot of information here. 100 students are in a year group, and then we've got some information about whether they wear or do not wear glasses. And it wants us to work out the probability of choosing a boy who wears glasses. And when you've got a lot of information like this, I like to organise it in a two-way table. So I'm going to put this all into a two-way table. Again, you could use a frequency tree, but I'm just going to opt for using a two-way table. So we could have boys and girls on the side. Again, you could have them at the top, but I'm going to put them to the side. And then you've got a total down the bottom. And then we've got whether they wear or do not wear glasses. And again, we've got a total here. So what I'm going to do is put the numbers within the question. We've got 100 students in the year group. 42 of them are boys. 8 out of 100 students wear glasses. So 8 students here wear glasses. And 52 of the girls do not wear glasses. So 52 just here. Now that's everything in the question. We've just got to fill in all the missing numbers now. So if there are 42 boys here, that must mean that there are 58 girls. And out of those, 52 do not wear glasses. So that must mean that 6 of them do. Now again, we've got 8 that do wear glasses, 6 of them are girls, so 2 boys must wear glasses. And again, going along this way, that has to add up to 42, so that must be 40. And then moving downwards or across from another direction, I could add those together to make 92. And a very quick check here, those two add up to 100, so that's right, we're happy with that, we can tick that off. Now it says, work out the probability of choosing a boy who wears glasses, and one of the students is picked at random. Well, 2 of the boys wear glasses, so that would be 2 students out of the 100 students that we've got here. You don't have to simplify that, but just a quick note, it could have said in the wording here, it could have said, rather than saying one of the students, it could have said one of the boys. Now if it had said it, maybe it had picked one of the boys, then that would have been out of 42, so it would have been 2 over 42. But it just depends on what the wording says, so it does say one of the students, it doesn't dictate whether it's boys or girls, so it's out of 100. I'm moving on to a Venn diagram. Now this symbol here just means all the numbers that we're going to put into the Venn diagram. So we've got the numbers 1 to 15, and then it says prime numbers and even numbers. Now what I'm going to do is I'm going to write down the prime numbers to start with. So we have 2, 3, 5, 7, 11 and 13. And we could write down all the even numbers as well, but I'm hoping we can recognise them quite easily. Now what I'm going to have a look at is which numbers are in both. Now the only even number in that prime list is the 2. So that's going to go in the middle because that says it's in both. So I'm going to cross the 2 off and cross it off from my main list. It then says, obviously we've got the prime numbers in set S, so I need to put all the rest into set S, so 3, 5, 7, 11, 13. Again, I'm going to cross them all off from my main list, so 3, 5, 7, 11, 13. And then all the even numbers are going to go in the right circle there. So we've already got rid of 2, so 4, 6, 8, 10, 12,
14. And again, just crossing those all off from the main list. So 4, 6, 8, 10, 12, 14. And the remaining numbers there are going to go around the outside. So I've got 1, cross that off, stick it on the outside. 9, cross it off, stick it on the outside. And 15, cross that off and stick it on the outside. Now we're asked some questions about the Venn diagram. It says list the members of SUE. Now that U stands for the union, and the union is everything within the circles. So that's the members of S, the members of E, and that number in the middle there. So if I write them all down, all the numbers there for part B are, from left to right, we've got 5, 11, 7, 3, 13, 2, and then all those even numbers, 4, 6, 8, 10, 12, and 14. Let's have a look at part C. Write down P, SNE. Now that P at the start there just stands for probability, so write down the probability that it's in SNE. Now that N is a different symbol again, and the N stands for the intersection. So this is asking me, what's the probability of picking the number that's in the intersection? Now in the intersection, we only have this number 2. So there's one number, so for that part C there, I'd say one number out of, because it's a probability, and there are 15 numbers in total. So the probability there would be 1 out of 15 for part C. Again, it could say SUE, and that would have been, again, we'd have to count all the numbers in the union. Let's have a look, there's 3, 6, 9, 12 numbers there, so that would be 12 out of 15. Now the final part here, it says find the probability a number is in set E dash, and that little dash just means not in. So E dash means not in E. So E dash, not in E. Now if we have a look, there are quite a few numbers that are in E. So all of these numbers here are in E. So all we need to do is have a look at how many numbers are not in E. So let's pick a different colour. Let's underline all the numbers that are not in E. 1, 2, 3, 4, 5, 6, 7, 8. So the probability of picking a number that's not in E is 8, again out of 15. So again, just remember that the little dash means not in that set, the N means the intersection where they cross over, and the U stands for the union, which is all the numbers within all of the circles. Okay, so the probability that Amy wins a game of snooker is 0.2. Amy's going to play 2 games of snooker, work out the probability she wins exactly 1 game. Now let's have a look at this one. So if we create a probability tree for this, we've got on the first game, which I'll label this branch as the first, she either wins or she loses. And the probability she wins is 0.2 and the probability that she loses is 0.8. Now she's going to play a second game, so I'm going to have a second branch. Again, this is after she's won, and we've got a second branch here in case she loses. But again, she wins or she loses, and she wins or she loses. Now it doesn't say the probability changes on the second game, so it's all just going to be the same. 0.2 for a win, 0.8 for a loss, and the same below. 0.2 for a win, 0.8 for a loss. Okay. So it says work out the probability she wins exactly 1 game. So she wins exactly 1 game, that's quite important there. Now the only way that she wins exactly 1 game is if she also loses a game. So this win-win up here is no good, and this lose-lose down here is no good. But here we've got the probability of a win and then a loss, and then here we've got the probability of a loss and then a win. All we need to do is work out these 2 probabilities. So to get to this second branch here, if we go to the start, we go up through the win and down through the loss. So that's 0.2 multiplied by 0.8. And 0.2 times 0.8 is 0.16. Looking at the second option there, she could lose and then win. And that just goes through 0.8 multiplied by 0.2, which gives us the same answer there of 0.16. So we've got our 2 answers there. We've got 0.16 for that route and 0.16 for that route, and when we've got 2 probabilities to combine, we just add them both together. So 0.16 add 0.16 gives us a total probability there of 0.32 as our final answer. So another probability question. James takes the bus to school. The probability his bus is late going to school is 0.3, and the probability his bus is late going home is 0.7. What is the probability that at least one of his buses is late? Let's have a look at creating a tree. So this time it's not the same thing on both occasions. We've got one where he's going to school, and the other part of the branch is where he's going home. But when he goes to school, it's either late or it's not late. and the probability of late is 0.3, so therefore the probability that it's not late is 0.7. Then we've got the next branch, which is going home. Now the numbers look quite similar here because we've got 0.7 in there again, but we've got late and not late, and again late and not late. But this time it says going home, the probability that's late is 0.7, so this would be 0.7, and again 0.3, and the same below, so 0.7 and 0.3. Now the question says to work out the probability that at least one of his buses is late. So this time it's not just one late, it could be late on both. So we could have the probability, let's do this in a different colour, we could have the probability that it is late and then late. We could have the probability that it is late and then not late, that's at least one, and the probability that it is not late and then late on the second one. But not late on both is no good to us, so we don't want that one. So what we need to do is work out these three probabilities this time. So late then late goes through 0.3 and then 0.7, which is 0.21. We've got the probability of it being late then not late, which is 0.3 times another 0.3, which is 0.09. And we've got that third one there, okay, which is not late and then late, which is 0.7 times 0.7, and that equals 0.49. So this time we've got three probabilities to add together, but because we've got a combination there, again, we just add them all up. So 0.21, 0.09, and 0.49. And altogether that adds up to, let's have a look, 8, 9, carry the 1, 4, 5, 6, 7, so 0.79 is our final answer for this one. Let's have a look at some with some fractions. Okay, so the hardest one out of the bunch here, we've got 4 red counters and 5 blue counters. One counter is taken and not replaced, and then a second counter is taken from the bag. Work out the probability that both are red. Now this piece of language here is important, taken and not replaced. So that's going to give us two options here when we do our tree, but let's have a look at the first option. So initially we've got red or blue. This is our first pick. And the red counters, there are 4 out of a total of 9, and the blue there are 5 out of a total of 9. Now let's just have a look at this second pick to start with, and let's imagine we took a red. So if we take a red, what have we got now? We've got 3 reds left in the bag, and there are only 8 counters in total, but none of the blues were taken, so we still have 5, and that balances out to 8 there on the bottom, so we've got that option there. Now because this is going to be different, taken and not replaced, the second part of the tree is now going to be different, because if we go back to the start here, we've now got to imagine, okay, well what happens if we took a blue? Well, we still have the option of taking a red or a blue, but this time the blue has been reduced to 4, so still out of 8 now, but it's going to be 4 for blue, and balancing that out, there's still 4 reds in the bag. So we've got 4 out of 8 this time for the reds. Now we've got an easier question for this one because it says work out the probability that both counters are red. Now that gives us only the option of having this branch here, the probability of a red and then a red. And to get that root there, we just go through red on the first root and red on the second root. And that gives us 4/9, and again we multiply by 3/8. Times in the top gives us 12, and times in the bottom gives us 72. So our final answer there would be 12 out of 72. Again though, if we were asked different questions, we would work out multiple roots and we would add them together. All the fractions here are going to be out of 72 because the denominators are always going to be 9 times 8. So our fractions are going to be nice and easy to add together. If we imagine that it said probability of getting 2 reds or 2 blues, the probability of 2 blues down here would be 5 times 4, 20 over 72, and that's nice and easy to add to 12 over 72 because you just add those numerators together. But it's the same process, multiplying across the tree and then adding to combine any probabilities at the end.
Okay, well done for making it to the end of the video. That is the end of our revision there. As I said in our previous video, do make sure that you conduct your own subject analysis. There are an awful lot of topics across these videos, and this is by no means every single topic that could possibly come up. There are other styles of questions and different elements, so do make sure that you have a look in the description at all those different topics and go more in depth in the ones that you don't understand. But there we go, there is the end of our video. I wish you the best of luck in your exam, and I'll see you for the next one.